tell you it's gone way too far. No, nothing gonna help you when it falls apart. The prophets and the preachers told you, but you covered your ears, and now the end is near. Gonna tear it all down. 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 Call it revolution, call it whatever you need. Make a resolution, battle till you bleed. Prophets and the preachers warned you, but you waited too long, and now your chance is gone. Gonna tear it all down. 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 Let it all burn down in the fire. Let it all go down in flames. Let it all burn down in the fire. Let it all go down in flames. Let it all burn down in the fire. Let it all burn down in the fire. Let it all burn down. Ooh, let it all burn. Ooh, let it burn. Let it all burn down. it crazy. Oh, it can try, but it will never stop me.
Choke it up. Roll it up.
Test mic. Yeah, yeah. That's it. Thanks. Test mic. Yeah. The what? Yeah, yeah. I can hear myself. It's good.
Don't know what day it is, but I know that I wanna spend it with you. Won't act so innocent, be careful to know that I'm telling the truth. Sorry I made you love me, sorry you weren't one. Sorry I made you love me, sorry I'm who you adore. I was just bored, bored. I was just bored, bored. I was just bored. No, I was bored. It's ridiculous. Promise I'm not trying to make you a fool. Promise I'm not trying to make you a fool. You just need some insurance. Your eyes fall out when I walk in a room. When I walk into a room. Sorry I made you love me. Sorry I'm who you adore. I know how bad you want it, but you're not getting more. I was just bored. I was just bored. Bored. I was just bored. I don't wanna watch you take it too far, and I don't wanna see you leave you a scar. I don't wanna watch you run away, run away, run away. I'm so bored. I don't wanna see you. Sorry you weren't one. I know how bad you want it, but you're not getting more. I was just bored. I was just bored. Bored. I was just bored. No, I was bored with you. No, I was bored. I know how bad you want it. Bored. I punch in my card, I know what it costs. Yeah, I put in the work that you don't. Day after day, I work and I play. Yeah, I'll do all the things that you won't. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. 'Cause every time the push comes too sharp, climbing over you to reach the top. 'Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. 'Cause I want everything and nothing, 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 nothing at all. Don't care what you think or what you believe, 'cause I'm gonna turn the world upside down. If you want a shot, just step in the ring. Yeah, I'ma shake your bones like thunder. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. 'Cause every time the push comes to shove, I'm climbing over you to reach the top. 'Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. 'Cause I want everything and nothing, 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 nothing at all. I don't want nothing at all, unless I can have it all. I don't want nothing, nothing at all. I don't want nothing at all, unless I can have it all. Nothing at all. Yeah, I am not the favorite son, but I'm the one who's been here all along. 'Cause every time the push comes to shove, I'm climbing over you to reach the top. 'Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. 'Cause I want everything and nothing, 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 nothing at all. I don't want nothing at all, unless I can have it all. I don't want nothing at all, unless I can have it all. No, I don't want nothing at all, unless I can have it all. they tell you it's gone way too far. No, nothing gonna help you when it falls apart. The prophets and the preachers told you, but you covered your ears, and now the end is near. Gonna tear it all down. 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 Call it revolution, call it whatever you need. Make a resolution, battle till you bleed. Prophets and the preachers warned you, but you waited too long, and now your chance is gone. Gonna tear it all down. 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 feels just right. Oh, you know you got me. And we can watch the sunrise and welcome a new day. Oh, if you just stay here, you know you got me. And oh, this is the start of something beautiful. And oh, this is the start of something you should know. Oh, you got me. Oh, you got me. Whoa. Oh, you got me. Oh, you got me. This is like a movie, the whole world can watch us. They'll be in awe of just how much you got me. There might be some hard days, life might get crazy. Oh, it can try, but it will never stop me. Oh, this is the start of something beautiful. And oh, this is the start of something you should know. Oh, you got me. Oh, you got me. Whoa. Oh, you got me. Oh, you got me. Whoa. And I can feel your heart beating close to mine. You're like gravity. You're pure in me. You're pure in me.
1, 2, hallo? Works. Nice. Yeah, good morning everyone. Welcome to the second day of NeosCon 2022. Yeah, and welcome on the studio stage. So the first talk will be about Redux and React. I guess pretty much a lot of people use this in their daily businesses.
Yeah, for me especially, it's my bread and butter. I use it basically every day of the week, and I really enjoy the developer experience because React combined with TypeScript, that's really a whole new world if you're used to normal JavaScript. And yeah.
Yeah, and I know I see a lot of some faces in the audience that think similar, I guess. Okay, so welcome on stage, Devlin Dudulau, and the stage is yours. Enjoy.
Yeah. Thanks. So yeah, again, good morning, and just a quick thing about me. Again, Devlin Duldulao. I'm originally from Manila, Philippines. Now working and living in Oslo, Norway, for 3 years now, doing a lot of enterprise web application and mobile and backend. So I would assume React user with a little bit of experience in Redux, or haven't tried it. So that's good. Okay, so yeah, a few. So yeah, this talk is about Redux, all about store, how do you set it up, maybe if you have time, how to set up tests also, how to persist the global state in local storage, and the new feature. Actually, it's not new feature, it's additional feature in Redux Toolkit, which is the RTK or query API. If you're familiar with the React query or Apollo client in, when consuming GraphQL, you'll understand how it works because it's related to caching. Yeah, this is all about Redux Toolkit actually, because Redux is another library which is an old. Redux Toolkit is the new. So without further ado, so libraries, let's check out libraries that we will be needing here. So yeah, you can add Redux to any type. This is the first thing. Any type of application you're using. It could be React, Angular, Vue.js, vanilla JavaScript. It's a JavaScript library for managing states in an application. Another one thing is the React binding. So you can see React dash something, the Redux. So allows us to integrate Redux in our React application, and it makes it very easy for us to go and get states, right, that we are storing inside Redux. What else? The Redux Toolkit. This is the official opinionated batteries included toolset for efficient Redux development. Right? It includes that the query feature that I mentioned, also the Tunk. Before you install Tunk when you're just using the plain Redux before, but Redux Toolkit is another library we'll push later. So we'll get back to this later. Redux Toolkit. What else? The Redux dev tools. You will see why state management, why Redux is different from just using the built-in, store management in React, because that's not actually state management. Because state management will give you this these dev tools to play or replay what's happening in your application, right? State management. So yeah, we need to know what does Redux solve in React. The props drilling. So this is a typical problem in SPA, in single-page application. If you have nested components, right, and your customer or the product owner or the owner of the application asks you to what? Oh, I want this part of this part of the profile of the user to appear here, and when you change something here, it should also reflect here, right? So that's the problem here that we're fixing. It's not simple, when two different components in very deep in a deep level of your application needs to talk to each other, or if you need the values that you're changing will reflect in that another component. Otherwise, you'll be passing props, passing events, passing, and it's gonna be spaghetti if you don't have this store. So store basically, you can reach to this global state in any component. That's the beauty of it. In any component, you can just get the state, and it's reactive. So meaning the changes will appear in any component where you're using it. So yeah, what store contains the app state? Let's make it faster. One store per app, by the way. Each store can have many reducers or slices, also known as slices of state. So a quick flow of Redux. So not sure if I can use my mouse. Can you use? Okay, can you see my mouse? So the first thing that's gonna happen in the setup of Redux. So you have this store, right? And in any JavaScript framework and state management, you always need initial value. So remember that even in Vue.js, there are two popular state management library in Vue.js. In Angular 4 or 5. In React, you have this Sustand, you have this Mobx, you have this Redux, right? All of them have this common thing that they're doing. You need to put some values, initial value. Could be an empty string, as long as there's an initial value, or an empty array, right? And then, to show that value from the store, you need a selector. So you have to remember this selector. Selector is to render that value in the component. So you need that. So after rendering the values here through selector, of course you need to edit it, right? You need to change the array, add something, right? It doesn't matter whether you need an HTTP request or without HTTP request. So in that case, you need a dispatcher. So you need to remember dispatcher. But dispatcher is a function that it's like, imagine it's a messenger. So it tells the reducer, or it tells the store what's gonna happen, which part of your store will have to be updated or deleted or will be added something. So it sends the message to the store what to change. However, in dispatching action, there are two things. In action, an action with side effects, meaning that's why it's side effects, meaning you're not sure what's gonna happen if you're sending something in the server, right? It could be 200, okay, or it could be a 401, or it could be 503. That's why it's called side effects, because you're not sure if your request to the server it's gonna go through. So there's a side effect. So that's an action with side effect, and an action without side effect. It's easier if the action doesn't require HTTP request, because it goes directly to the reducer, and the reducer will just remove, update, add your data, or your data in the global state. However, if there's side effect, you need to check first if it throws an error, if it's 500 or 200. If it's 200, okay, do what you want to do. If it's 500, of course, the reducer will not do it. So this is the typical flow. This is also applicable in Angular, by the way. If you'll be using Angular one day, it has Redux. So this is the flow. You have this selector that extract the data from the store. You have this dispatcher, right, to send the action, and side effects, and then reducer. So let's go to Redux Toolkit. So in Redux Toolkit, let's go to Redux first. Best practices: do not mutate the state. The first and the most important one is that we are not allowed to mutate state in our store. We have to create new states and replace existing state with that state. You'll often see that spread operator in JavaScript, in modern JavaScript, right? The spread operator, because it will create a new memory in your application, right? Or a new reference, by the way. So the way it's like in React, the diffing. So when you use a state, it kicks in the diffing of the React to know that, okay, there's something that I have to re-render. That's why also in Redux you have to use this spread operator, because it creates a new memory in the application that will trigger the reconciliation in React to create this reactivity. Reducers must not have side effects. You don't send HTTP requests inside the reducer. It's the HTTP request is in the outside, right? Do not have non-serializable values in state or actions. You don't write classes there. Okay. So yeah, only one store per app. So Redux Toolkit, let's go here, simplifies Redux code. There's maybe 20% boilerplate that has been removed if you'll be using Redux Toolkit versus the old Redux in React. Opinionated, right? It's very opinionated. Actually, Redux itself is already opinionated. This is more opinionated, but it removes those boilerplate. Good defaults for store setup. You have these guidelines because it's opinionated, easy to set up. And most commonly used Redux add-ons built in. Like I said, with Tonk already in some things. And there's another one to normalize data. It also has this built-in to normalize data. If you're fetching this nested objects with nested array and you want to normalize it, Redux Toolkit has it, this normalizer. Less boilerplate. Okay, how to use it? Just run npm install Redux, React Redux, the binding, and Redux Toolkit, right? Okay, before the demo, okay, again, things to know, actions, okay, payload for of information for your reducer. Um, yeah, this is how it looks like. The dispatch. So you have this dispatch that you create, this hook, and dispatch, and then you have this action. Just very quick here. What else should we do? This is the old reducer, by the way. I'm just showing you the old reducer here. And again, the initial state, which is applicable in any JavaScript framework. This is very basic. You always need the initial state. And the old reducer, which is a big switch case. This is the old Redux Toolkit. You'll not be using the big switch case. You'll be using reducers, and then you have this state and action, and one thing that's already also built into this RTK is the emmer. So I mentioned earlier you use dot 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 spread operator, right, to create a new memory in your application. Where in this case you can mutate. Best practice: do not mutate your data. But in Redux Toolkit, since you're using emmer under the hood, which is also the author of emmer, by the way, it's also the author of MobX, which is another state management in React, by the way. Yeah, you're basically you can mutate here your data. Just you don't have to spread operator or something like that. Yeah, so this is changing your state in non-async or synchronous without side effects. What about with side effects? Extra learning here, extra reducers. This is for your actions with side effects, meaning actions that you use when sending HTTP requests to the server, right? So yeah, store, aka single source of truth. What else? Configure store. So this is the setup in your store. Combining all the reducers or slices, and basically that's it after creating this. So if, for example, you only have one reducer here, later I'll show it to you. So yeah, look at here, it's just Redux Toolkit, lesser boilerplate. And then, of course, in React, there's this provider that will trickle down the data from the provider, giving it access to all components in your application. And it looks like something like this. You have the provider, and then passing the store that you created earlier, which is this one, right? And then that's the setup. Then after that, the uselector, right, to render your data. So uselector, the name of your reducer. There's a way to give you IntelliSense, by the way, through TypeScript. There's an extra setup, but of course, that's an investment of time, because TypeScript will give you IntelliSense and static typing. So uselector, curly braces, heroes, and then you can just render it. So this is the selector I was referring earlier. So yeah, the demo. I think it's here. So I have this server running already through JSON server, and let's see here. So Redux Toolkit, right? This is the RTK later. So for the heroes, this is the RTK later. I'll show you the RTK query for caching. So after these heroes, there's another one, VLanes page. Well, anyway, let me show you how to set it up. Where's my mouse? So first things first, when you're setting up Redux after installing the libraries, right? So you have these features, which is part of the naming convention, where you put your slice types or actions, so features. So for example, here, heroes, and if you're using TypeScript, or even if you're not using TypeScript, so we have this, let's go here first, hero state type. This is what we're going to use in the reducer, especially in initial state. So we're adding typings here, by the way. So you can use interface or type in using TypeScript. So this is for the state type. Another one would be at another type or another interface you can use for the hero. So ID, first name, last name. Yeah, namespace, it's better to do it here, so you have one place where you can edit it, right? Not just typing it, and make this and have this typo error. So it's better to have this. Action types, you would need this if you're dealing with side effects. Why do we need this? This will be registered in your Redux toolkit. You don't need this, but it's good to have this so that later, and where's the, it's already here. Let's say the Redux dev tool. And it's not appearing. I was just testing this. Anyway. Oops. No, that's okay. Wonder why it's not appearing now. I was just testing this 5 minutes ago, so yeah, let's go back here. And yeah, after typing this, after adding these types, you can now go to slice, right? Yeah, initial state. So you can see here just an empty object, empty array. Even the loading has initial value, which is false. And for the slice, so you would need this create slice from the Redux toolkit. And adding the namespace, we created it so that we don't have to type this to do this, right? You can just use it here. Initial state, again, you don't have to do this, but it's good to put it in a separate location. You can just copy this and put it here. But it's gonna be untidy because here's everything now. Yeah, mutation, synchronous. We have this trigger loading, remove hero from store, save hero list. So let's try this. Trigger loading, right? How do we trigger that? Yep, you have loading. When you go here, to the pages, what's this? Dispatch. We have this get heroes action. Okay, dispatch, the dispatcher, get heroes action. This is defined in, let me show it to you. Here in hero action, because we're sending requests to a server, we need data, right? We need data, but these data are coming from an API. That's why we have to use these heroes sync async actions. This is part of, will be part of the Redux toolkit for the side effects. And the way to set it up, this is another learning curve in Redux toolkit. You need to use this create async tank, hero actions, the key value pair, async, HTTP calls, right? But if you're new to Redux and you don't want to learn to do this extra learning, this create async tank, select what is this? Although you have this Axios, your HTTP client, you can basically just do this. Fetch. And then after fetch, this is the built-in in the browser fetch. Then the response, using the response, dispatching it, save hero list data for the action to save the data coming from the API. Although this is not recommended, but again, you can do this to just remove, or if you don't want to do that extra learning of this side effects in Redux, you can basically use the fetch or Axios, your HTTP client, get the response from the API, dispatch the data. Of course, you need this dispatch, and save hero list, which is the action to save the data from the store. Yeah, but again, this is not the best practice, but still, just to remove that extra learning for the Redux. The idea in Redux, what they're recommending is, since these are what? These are business logic, right? This business logic should be located in the slice. So that's what they are recommending here. Adding the business logic in this reducer. So it's up to you. It's up to you. Do the business logic in the component level, or do the business logic inside the extra reducers. Although, again, this is another learning, right? So, let's go back to slice, action. Save hero list. That is what you're seeing in the heroes page. Save hero list to get the data. So this is the data from the web API. It's in JSON. So save hero list, as you can see. We can go here. Save hero list. State. State is an object where you put all your state, all your data. So actually, this is it. To have the access here. So here we're updating the heroes from empty array to data with superheroes. So we need this. We need this to be updated. That's why here, state.heroes, action, payload. What is this payload? This payload is this one from the web API. That is the payload. That's why we're mutating it here. Dispatch, save hero list, the payload, and when you go back, this is it. This is the JSON response. Right? So, yeah. Remove hero from store. What are we doing here? We're removing one hero from store. You can use splice, or here, one-liner filter. Payload again. What is this payload? When you go here, heroes page, handle delete hero. No, it could be here. The ID of the hero. So dispatch, remove hero from store. That will remove the hero with this ID. So filter, just give me everything except that, that hero with that ID. So that's how you mutate it. Anyways, okay, so you already have this, some actions. These are the actions, by the way. You already have this. So my tip for you is just write this one by one. Don't try to write a lot of actions in one sitting, or in without testing your Redux. What I mean by testing is, you have this save hero list. Try to see if it's working. Start building your store, or setting it up. So you need this configure store from Redux Toolkit again. Name it Redux store. Preload state, this is something that you might use if you're planning to save the global state in the local storage, right? It's coming from Redux local storage because it's common also to to be asked, hey, developer, please, let the user still have the data when they refresh the page, because the QA will start complaining, hey, when I refresh the browser, all the data is gone. So that's a typical scenario of what you'll get from a QA, from a tester. When they reload the browser, all the data from the global state disappears. So in order to persist that, if you're planning to have this user experience where they refresh the browser, the global state is still there, is through this Redux local storage simple. And there's another one actually, Redux persist, but I found this very simple to use. So yeah, that's a scenario of, in real world, the QA will try to break the application and will complain, the data is lost. Why not persist it? So this is how you persist the global state in the browser. Okay, reducer. You need this object. And what do you put here? Your hero slice reducer coming from, actually here, all the way here. After writing the reducer, you need to expose this. By the way, this is how you expose the action, so you can use it in the component, right? The old way of reducer, the old. So you can see that there's a big difference. And then to use this, to import this, I think it's already imported, exported pala, sorry. Exported, no, this, where's it? Yeah, here, export. So it's already exported, and then you can import it in the store. So if you have another reducer, let's say VLanes or super VLanes or other slice, just register it here, like so. Oops. Something like that. And the rest will be here. All the reducer. So once you set it up, so this is just the one-time setup, and then you're done. Yeah, if you found this too much to learn, don't worry. Once you set this up, it's already okay. The future slices or reducers will be just added here one by one, and then yeah, it's just one-time setup, and then you're done. So don't be afraid of learning this stories. Just how many lines of code? It's just, if you're using TypeScript, you will still need this for typings until here, but plain JavaScript, 20 lines of codes only. So this is only for by the way, for TypeScript users. Root state, so you have this intelligence of what you're adding here, by the way. So how do you access this reducer, your global state? If you're using TypeScript, you need that intelligence, right? Let me show it to you. So you see the typings that we're creating here. So you'll get this. Yeah, because of that setup. Just one-time setup also for TypeScript. And if you have 10 or dozens of reducers, everything will be here when you dot. Use app dispatch, use app selector. And by the way, these are not something that I made up. They're all in the documentation, by the way, of the Redux Toolkit. These are, the documentation also already good. All boilerplate and samples. Even how to configure your Redux with test utils. Here, This is not something, don't be afraid, this is not something that I just wrote by myself. I just copied paste this from the documentation. And what is this? This is how you set up Redux with Jest, so you can write unit tests or integration tests or component testing in your React application if ever your management asks you to write tests, or your tech lead or your lead developer asks you to write tests in React with Redux. This is how you would do it. And again, it came from the documentation. I just copied it and pasted it there, here, and then it started working. Basically, you're doing everything. Your components. Let's go to the app.tsx. It's just the same. That's the idea, right? Provider, CSS baseline for this is material UI, browser router from React Router DOM, navigation bar, container, lazy routes, doing some lazy routes. So you just need to be able to do this in your setup of tests, so you can write tests. Maybe we can run some tests here. Hopefully it will, where's it here? How many tests we have? And it's passing, right? Cannot see. So sample tests. Yeah. By the way, this is a React testing library. So, yeah, let me show you what is a React query. So we're almost done here with the heroes. Now let's go to RTK query. But before that, let me show you the difference between RTK query and the Redux. Let's go to master. No, discard changes because I edited something. So you will see the difference of caching, and it's gone. So Redux Toolkit query. Please take a look. What's gonna happen here? So loading, you see that, right? Loading in the heroes page. In the VLanes, there's a loading, but it's very quick, right? Let's go back to heroes. Loading again. Now let's go back to VLanes. There's no loading anymore. Always seeing that loading. In RTK, there's no loading. Why? Because of caching. So how do you do caching in the Redux? So which is very helpful. But before that, let's go to syncing states in complicated nested components. So in managing complex state for syncing or reflecting changes in states in different components, we have to consider two things, or divide your global states into two things. Client state data. What is client state data? And we have API data. So this is what we're trying to put in the global state. So we have to divide these two, client state data and API data, and then you'll see what are these in state management. In client state data, a global client state data for example, for user settings, team, right, etc., and API data, which is our server requests or remote data, right? Just to separate them. So in API data, we can improve the data coming from the server by applying caching, optimistic update, and auth fetching, which you will see later. So as you can see here, user settings, theme, dark theme, light theme. This is something we can put it in the store, but this doesn't require HTTP requests, right? Settings and then light theme, dark theme. You don't send requests to the server and then get the result here. However, array our collection or remote data, this is important to know because we can apply caching here. Because we don't need caching here. This is already in the browser. In remote data, data coming from a server, it's good idea to apply caching. Why? Again, you see that earlier when I go to the VLanes page and the heroes page gives you this loading, right? Spinner. When I go back to VLanes page, there's no loading. That's a very good user experience, by the way, for your user. To not let them see this, user. And one more thing, I don't have an example here. If you have like blog post or a store where you can go to the detail store, for example, Pokemon, you want to see Pikachu. If you're caching that, you went to Pikachu, right? You go back to the list of Pokemon. You went back to Pikachu. It's already cached. It will just give you it instantly without waiting for the response of the server. So that's the beauty of caching it. And actually, you can do this to using React query, but it's already something that you can use from the Redux toolkit. So you don't have to install this, by the way. And this is really something that's very popular in React when caching data coming from the backend to give you this good user experience. So RTK query, what it is, what problem it solves, what APIs are included in RTK query, basic RTK query usage. So we have these queries. The most common use case of RTK query operation can be performed with any data fetching library of your choice. Mutations, mutating data, updating data in the back end, right? And RTK has this cache behavior, right? So, which is I showed you earlier. So let's go back to that code. Or again, here. Heroes without cache, with cache. So how do you implement that? In Redux, which is already built in. Let's go here, RTK query. So, in RTK query, so I removed the Redux here, by the way, just to give you these lesser files. You don't see the heroes anymore, just the VLanes. So in VLanes, just write query.ts. We have an interface here of the VLane or the type model. Create API. This is what you need. This is reducer path for the VLane. Base query. So all of these are something that you can find also in documentation of RTK. You need this fetch base query, which is already an HTTP client that will also cache your data. And what are these? In React query and here in RTK query, you need these tag types, these tags. What are these? This will ID the cache. So this is for letting the RTK remember, hey, please cache this. So if you have a dozen of data that you're caching, of course, for the RTK to see which one are you editing, you need to ID them. And this is like an ID. These tags here. Just an ID, just to give the RTK that this is it. Okay, yeah, the HTTP client in RTK. We have this fetch VLanes. That's going to be one HTTP request. Builder.query, your typings, return void, and you need this inside this curly brace, this function, this query that returns. Actually, this is the path of the HTTP. This is the endpoint, by the way, because you already set it up here. You have this base URL, right? Which is has a proxy. So you just append this. It's just like, yeah, this is the same as this one because we already have a base URL, right? So add VLAN, query, request. This is coming from the form, right? When you're sending data, put it in the body method. You have to tell the RTK this is a post. Again, the URL is gonna be something like this. Because you have the base URL, right? That's for the add VLAN. Remove VLAN, method delete, and then this one. And what's good here is maybe I can show it to you, which is already, oh, it's gone. Maybe I did something. Wait. Oops, not this, but then let's remove this. Ah, okay, yeah. Sorry, because I just refreshed it. So here we go. Does it send? But anyway, yeah. Then sending requests. Mm-hmm. 201. Think I touched something here. But anyway, even this one, this Redux toolkit, Redux dev tool, suddenly disappears. Yeah, I was just testing it. I don't know why it's not appearing the dev tools. It was like earlier this year. Too bad we cannot. I cannot show you the replay. Why it's not appearing here? It's weird. Although it's here, Redux. But I cannot see the UI of Redux dev tool. Yeah, maybe. Let's see. Redux. Okay, here you go. Okay, that's it. Now it's here. So if you're not familiar with the Redux, this dev tool, basically you can see the action here, and you can see also some diffing. So first of all, what's happening? So VLAN, some initialization going here. Next thing that happened, we have this hero fetch pending. Hero fetch heroes fulfilled. Let's remove. Let's remove. It's being recorded, right? It's being recorded, and then you can replay it for debugging. This is for debugging, by the way. And then what you need, what's good here is, in a specific point of in time, you can check the state if it really remove something. For example, how many heroes we have here? 3. And here, remove hero from state. You can see that it's 2. This is very good for debugging. And this is something that you will not have if you're not using state management libraries. If you're just using the built-in in React, I forgot that name. The what's that name again? The in React, the built-in for managing. They have this. Yeah, use context. Thanks. Yeah, you wouldn't have this in use context, by the way. So that's the difference between what is use context. But because some developers say you already have state management library built in React. No, that's not state management library. You don't have DevTools there. You cannot replay what you're doing. Here for debugging purposes, you can definitely do this. You have pending, right? Okay, pending, we have pending. Because I already, wait, refresh. Oh yeah, it's I thought it's from zero, from empty array. You know why? Because of because pending should be an empty array because what? In our features in slice, it's an empty array, right? But in pending, there's already 1, 2, 3, 5, 6. Where's it coming from? It's coming from local storage. Right. Let's going to remove the Wi-Fi. Refresh it. It's already there because I persisted it in the local storage. That's that I talked about earlier, right? That library. It's really good to use. So yeah, that's yeah. I think that's all I've got here. What is Redux? What it can do? What is RTK? How to set it up with the tests, and how to add also how to persist it in local storage. If you want the repo of those, set up with TypeScript, with this is like everything already with TypeScript, with JS test, with Rack testing library, with persisting to local storage, RTK query with side effects, without side effects. Everything is there. You can just go to this repo on my GitHub, and then yeah, just play around with it. If you want to apply this in your own application in the future, I still keep on updating this, by the way, because I've been reusing this for the past 3 years now. I just changed the number, but it will still be the same. It will be redirect you to this repo one day. So yeah, this is what I use in every workshop of Redux React that I'm doing. And yeah, just download the repo or just book it more, or yeah, so you can use it one day in your project just to play around and see. Because every thing that you can use in Redux is already here, except that normalizer that I mentioned, because it's already advanced normalizing data. If it's something that screwed data with nested objects and array, and you want it to be in a data structure that you want, normalizer. But anyway, yeah, I hope you've learned something here. This Redux with TypeScript and RTK query, the caching, right? Giving you giving your user best user experience because of the cache, that they wouldn't see the loader anymore or spinner. So, and then with optimistic update also, by the way. So yeah, thank you.
Thank you very much, Devlin, for this very in-depth insight into the Redux toolkits.
Yeah, thanks a lot.
So we running a bit late, so we'll go through the questions very fast. So I have a quick question about...
Yeah, I have some questions as well, but let's first check maybe if there are any questions from the audience or from... Okay, there are no questions.
Yeah, I saw
so
that's empty.
Then please start.
About the Redux toolkit and using it in a project, what do you do when can you ever update the whole toolkit, or is that even not practical, or is it super easy to update the whole toolkit because it's a combination of different packages and technologies? Can you just is there an easy upgrade path, for example? I noticed, is React Router part of the toolkit, for example?
No. It's not, the React router is not part of the toolkit, but it's also in the repo, by the way. I'm using the latest React router there, the React Router 6, and there's two different way I set up the routing with lazy loaded or code splitting. The other, that's what I called lazy loading component, lazy routes. The other one, this the normal routing, which is eager routing, right? That's why you'll see two different routing in my sample repo, because I separated the code splitting, the lazy loading router, and the other one with the which is the declarative, but it's an eager way of basically it pulls everything already, the resources. But the code splitting will just give you the files on demand, the resource on demand as you navigate to different pages, right? But it's again, it's not part of the RTK, but you can use it. You can get it from my sample repo.
Eric, your
Okay,
question?
yeah. So I want to ask one question. I had two, but I guess one of them is pretty stupid. Okay, so my question is: you showed us how to cache Pikachu, which is very nice, and I guess many of you Neos and Fusion users are familiar with the invalidation of cache by tags. So my question would be, as far as I understood, you invalidate your own tags, but that works only for the same client, right? Or does the server response also can invalidate tags on your local state? Like when two users are adding variants at the same time, for example.
When two users editing the same files at the same time, I think that's a good approach there is to explicitly invalidate, right, the data. So when they did an action, and when they do an action, they will see the latest changes based on the API from the data from the server or from the web API. However, if you do caching, you wouldn't see that loading again, that pesky spinner loading. It will just do an optimistic update, so it still gives your user a very good user experience.
Okay, so as we all know, caches are evil and hard to invalidate. Yeah, but thanks for the answer.
Yeah.
And
you got some more questions?
one last quick question. You already mentioned the use context hook from React, and you also said that it's not really a state management system like Redux is. And I really like the new leaner Redux with less boilerplate code. But would you also recommend using Redux for, let's say, rather super smallish project? Is there a certain scaling going on? Would you recommend Redux for every project you make?
This is a very good question and debatable whether to use
Maybe not that
Redux.
fast question.
Just in my opinion, since Redux is the #1 state management library, and most companies are looking for React developers with experience in Redux. Yeah, I guess it's because the problem, the complaint of developers is this boilerplate when setting up Redux, right? But you know what? Just setting up the store, it takes a few lines of codes, right? But once you set it up, it's there, and you don't have to update it again and again. And it's actually an investment also. Investment also for other onboarding developer, because probably they already know Redux. And yeah, just to answer that question, yeah, I would recommend using Redux from the start, even your application is small, because the application tends to go large, right? So, but if you already set it up there in the beginning, even if it's small, when you see that it's growing, there's a little change that you have to add in the existing, repo, because you already set it up. You have the store, and you have this already pattern of your reducer. You have these features and slices. You already have this pattern. All you need to do is create a new file, vlanes.tsx, something like that, slice, and then there you go.
Thank you very much.
Okay,
And we also have a little present for you.
Oh, thank you, thank you.
That's gin,
Oh, it's
sponsored
gin.
by Tech Division.
so I'm not so much into alcohol, so I don't know about this gin. But if you want to know, please ask the guys from Tech Division because I
Yeah.
guess they know.
Thank you. Thank you. Yeah, thank you, everyone. Thank you, Neos.
Big round of applause
this.
for Stefan again. For Devlin, of course.
Thanks. Thanks for the gin also. Thanks, guys. And yeah, don't hesitate to ask me questions later when we're having lunch or something. I'll be there to answer it. Yeah.
day it is, but I know that I wanna spend it with you. Won't act so innocent. Be careful to know that I'm telling the truth. But sorry I made you love me. Sorry you weren't one. Sorry I made you love me. Sorry I'm who you adore. I was just bored. Bored. I was just bored. Bored. I was just bored. No, I was bored. It's ridiculous. Promise I'm not trying to make you a fool. Promise I'm not trying to make you a fool. Boy, you just need some insurance. Your eyes follow mine when I walk in a room. When I walk into a room. Sorry I made you love me. Sorry I'm who you adore. I know how bad you want it, but you're not getting more. I was just bored. Bored. I was just bored. Bored. I was just bored. I don't wanna watch you take it too far, and I don't wanna see you leave you a scar. I don't wanna watch you run away, run away, run away. Ugh, I'm so bored. I don't wanna see you. Sorry you weren't one. I know how bad you want it, but you're not getting more. I was just bored. Bored. I was just bored. Bored. I was just bored. No, I was bored with you. No, I was bored. I know how bad you want it. Bored.
I punch in my card, I know what it costs. Yeah, I put in the work that you don't. Day after day, I work in the play. Yeah, I'll do all the things that you won't. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. Cause every time the push comes to shove, I'm climbing over you to reach the top. Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. Cause I want everything and nothing, 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 nothing at all. Don't care what you think or what you believe, cause I'm gonna turn the world upside down. If you want a shot, just step in the ring. Yeah, I'ma shake your bones like thunder. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. Cause every time the push comes to shove, I'm climbing over you to reach the top. Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. Cause I want everything and nothing, 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 nothing at all. I don't want nothing at all, unless I can have it all. I don't want nothing, nothing at all. I don't want nothing at all, unless I can have it all. Nothing at all. not the favorite son, but I'm the one who's been here all along. 'Cause every time the push comes to shove, I'm climbing over you to reach the top. 'Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. 'Cause I want everything and nothing, 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 nothing at all. I don't want nothing at all, unless I can have it all. I don't want nothing at all, unless I can have it all. No, I don't want nothing at all, unless I can have it all. I don't want nothing at all, unless I can have it all. I don't want nothing at all, unless I can have it Anybody tell you it's gone way too far? No, nothing gonna help you when it falls apart. The prophets and the preachers told you, but you covered your ears, and now the end is near. Gonna tear it all down. Gonna tear it all down. Gonna tear whatever you
Okay, so before the next talk is gonna start, yesterday we missed something, something serious. We missed to give the gin present to Michael. So please come on stage, Michael, and give him applause once again. Here's your gin, enjoy it. I'm not so much into gin, so please ask Tech Division or ask yourself, and you're welcome. And thanks Tech Division once again for sponsoring the presents.
So, and for the next talk, we have Timo Nussbaum with us remotely, and he'll be talking about using the Neos event sourcing in Symfony with a bridge. And Eric, do you have some thoughts on that?
Yeah, so I'm a bit happy to go back from the client to the server side. And yeah, I'm pretty excited about it because last year I've heard that it's actually possible to use many packages in Symfony from the Flow world. So yeah, that is cool. It sounds like collaboration to me.
Yeah, I also think that this will be a very interesting topic. And so without further ado, give a big round of applause for Timo Nussbaum.
So welcome to my talk about event sourcing in Symfony with a bridge. Nice to meet you in real life, not online. Yeah, that's what I wanted to say, but Corona had different plans. So therefore, this presentation is remote. I'm sorry for that, but yeah, I already downloaded the conference app. So please feel free to ask any question that you have, and I'm going to answer it after the talk. Important things first, I'm going to take you with me on a journey that ends up in a lunch break. That's really cool. You cannot imagine a more beautiful end, right? My name is Timo Nussbaum, and I'm working for a real small company directly in the heart of Stuttgart. It's called Evia. We develop a container shipping app that handles the logistics between China on the one side and Europe on the other, and China and the US. On the voyage of a ship over the ocean, a lot of different things can happen. On the current screen, you see, oh, sorry, not on the current screen, here, that's the current screen. On the current screen, you see one of several problems our customer had. A lot of my team members started to sweat at that time because of the just-in-time production that had led to major problems. Hopefully, I think anyone read something about the Ever Given in the newspapers. Normally, this ship should pass the Suez Canal, but something went terribly wrong here. And yeah, I always say we don't want to be agile, but we have to. This is a roadmap. If you leave this session, you should have learned the following topics. First, the basic structure and idea behind CQRS and event sourcing. Second, an understanding how the brand new Symfony adapter works. And third, parts of the Neos event sourcing that helps us to understand the main topics. Each topic, I also call it section, has its own icon. You can always see them in the higher right corner. If you have already dived deep into event sourcing, then yeah, you can breathe through the first intermediate steps. We are located in the understanding section at the moment. Before we start our journey, I want to map Symfony out a little bit. The idea is not mine, of course. Last year, I attended the Symfony Online Conference 2021. I listened to a talk by Dennis Bruman and Christian Floatman. They grouped the Symfony components into 4 layers. They discussed common principles for components. It's more or less based on package design principles that distinguish between core features, utility features, application features, and last but not least, framework features. The map shows us which components we can use standalone and which we can't. If you ask perhaps yourself why Neos doesn't use the messenger component from Symfony, yeah, well, it's pretty hard to set up this component standalone. This knowledge helps us to build better applications. Hopefully, a better Symfony adapter. After all, that's our main goal. We have not left the section yet. Still move right forward in the understanding area. Before we start to build our adapter, I want to look into dependencies. Neo's event sourcing uses already 2 Symfony components. This doesn't cause us any grief, but we have to find a solution what we want to do with the flow job view. I don't know. Does anyone use the flow job view already? I mean, it's something like you have a job, you put it in a database like MySQL, and later you consume it. That's really easy. So how can we handle that? In the first step, I try out if we can use the Symfony messenger or the process component instead. This could work because this component do the same or more or less the same. Furthermore, we need something for event dispatching because the event store definitely has to publish events later. In the documentation about the Symfony event dispatcher, you can read the component provides tools that allow you application components to communicate with each other by dispatching events and listening to them. Yeah, that sounds great. I'm going to grab it. So now that we have all the parts together, we can start now. So that's the big picture. And of course, after starting, it's really important to take the first break because it's always you have to do that. So in the next slides, I have some overlap with Sebastian's talk. Sorry for that, but it's important. And hopefully you all saw the talk from Sebastian two hours before. But without explaining the CQRS pattern, command query responsibility segregation, we cannot use this silver bullet that solves all our problems. In a talk, Gregory Young said, CQRS is simply the creation of 2 objects where there was previously only one. The separation occurs based upon whether the methods are a command or a query. Okay, a command is a request to perform an action that changes the state. Commands are imperatives like go to Neo's conference, bring me some beer. A command never ever returns any data. I tried that out with my children and with this CQRS, and I told them, clean up your room. And yeah, it doesn't work. There was always a response. And so perhaps the pattern is not 100% bulletproof. Okay, back. A query returns data, but it's not allowed to change the state of the object. What is the benefit of the separation? Okay, independent scaling, optimized read models. You can use different database technologies. For read model, you can use Elasticsearch, you can use Redux, you can whatever you want. And of course, separation of concerns, and so on and so on. In the center of our beautiful picture, you see the asynchronity barrier. The barrier is really, really important. Sebastian told you something about it. But just keep this barrier in mind. I'm come back to it soon. The right side. Yeah, let's start with the easy part of an easy pattern. The right side. We already know that commands are imperatives. There are requests that change the state. For example, create a new block. Commands are normally processed once. Events describe something that has happened. In our case, block was created. An event is something like a notification. Event should be named in the simple past. The event is committed and published to an event bus. Back to our adapter. We want to use Neo's event sourcing with Symfony, right? Okay, our first task will be to create a config file in our Symfony application with the following name, Nias_event sourcing channel. The config provided the possibility to use different event stores. For each store, you have to define the event table name, that's MySQL, a normal table, and the transport. I would suggest you start with the console command transport. It's a lightweight implementation. So next. So now we're on the read side. Back to the understanding section. On the read side, we have some subscribers who listen to events that are published on the right side. That sounds easy. The subscribers create projections out of these published events. Afterwards, you can query these new projections. You remember the important barrier between the write and the read side. Now it's time to deal with it. Keeping the projections up to date. Normally, an event is appended to the stream and the read model gets updated afterwards. You see it right on the bottom. The time it takes to update the read model is known as the inconsistency window. But that's part of another story. We have two possibilities to update the read model. We can do it synchronously and asynchronously. Yeah, spoiler, because Sebastian already shown the preferred way to go in this talk. The biggest advantage of updating asynchronously is that you can scale and replay the events independently. If you update the events synchronously, you lose these benefits, and it's not really easy to build a transaction around your write and read model. So that's not the way you should go, definitely not. But please don't underestimate the effort for eventual consistency and the delivery guarantees. Especially to implement a good solution for the delivery guarantees can lead to a huge effort. That's really important. So we decide to update the read model asynchronously. Alexei Tsimarev, hopefully I don't know if it's Tsimarev or Tsimarev, wrote in his book, the most common implementation for client-side projections is to use catch-up subscriptions. The term catch-up comes from the fact that such subscriptions, when first connected to the server, will read all the historical events and then automatically switch to real-time event processing. That's what he wrote. And yeah, but beside the catch-up subscriptions, the persistent subscriptions, also known as competing consumers, are really popular. Kafka use it. Azure Event Hub use them. But because Neos Event Store use the catch-up subscription, I won't into any more detail about competing consumers. But the main difference is the checkpoint ownership. Normally, I would say we can discuss this topic later at the bar or in the venue, but that seems to be impossible at the moment. But write something in the chat if you want to know more about it. So back to the catch-up subscriptions. Here we see two typical streams. In the order A1 stream, an order was created. The customer added a product, searched for another product, and also added it to the basket. During his search for the second product, another customer created an order, and so on and so on. That's easy. Under the two streams, you see the all stream. The all stream is it's something like a global stream. It means that every new event gets appended to this stream. Okay, we learned that the catch-up subscription will read all the historical data or events first and switch them to real-time processing. In our current example, the subscription created the document when the order created event came in. The later incoming events only update this document. On the replay, we flush delete this document and replay all the events. That's the theory. Let's look into the Neos event store. Normally, I would see smiles on your face because that's code. And this guy, it took around 10 minutes or 15 minutes before he showed some code, and that's really awful. But you see here the code out of the Neos event listener. You see that the listener used the catch-up subscription. After the event store is applied, the function reserves the highest applied sequence number. You see it on letter A on the screen. If no event has been applied, the number is -1. Letter B, it's up in the replay function. In the next line, the stream name is set. You remember the OR stream. If the event lister is not an instance of stream-aware event listener interface, then the OR stream is used. That's letter C. Otherwise, a static function listens to stream is called. Afterwards, the event store loads the event stream by the stream name and the minimum sequence number. That's letter B. That sounds a little bit strange, but not really. The events committed on the right side to the stream. The first sequence number of an event is null. At that time, there's no read models exist. So the highest applied sequence number is -1. That's letter B. The catch-up subscription is called the first time. Afterwards, the event store loads the first event. That's the event with the sequence number null. That's it. So we come now to the most important screen in my presentation. If I have done a really good job, then after this screen you understand everything, and that's cool. If not, I don't want to think too much about that. So we have lost a little bit the sight of our real goal, because I told you a lot about CQRS, the underlying idea. We know a lot about the different subscriptions, event streams, and so on and so on. But at the end, we want to develop an adapter that we can use in Symfony. It's time to bring all these individual pieces together. To auto-wire the Neos event store, that was pretty easy. We only had to register the store to the Symfony dependency injection container. That's a dependency injection container. Afterwards, we can commit an event to the store. The store itself publishes an event. So far, so good. But we have not dived deeper into the event publisher, a Symfony event publisher yet. The publisher is something like a wrapper. Everybody knows it from Typo 3. Everything was a wrap on Typo 3. Inside, it used the event dispatcher component from Symfony for resolving the class name of the listeners. What happens here? We have different listeners that listen if a new event is published. That you see in letter A, that are the listeners. If that is the case, the event dispatcher gets the listeners of the event and triggers an asynchronous transport to inform the listeners. That's letter B. The adapter can use the messenger or process component as transport. We come to the different transport soon. Let's assume that we use the process component, a new subprocess, asynchronous, called the catch-up subscription. This subscription builds read models out of our projectors. Let's look together in the main functions. We are in the adapter section. That's part of the code of the adapter. Here you see the brand new Symfony event publisher. The Symfony event dispatcher is listened to by the subscribers, which has incoming events. That's the first line. If that is the case, a subprocess with the listener's class name and event store ID is called. The rest should be clear. So now it's time to come to the different asynchronous transport that you can use with the adapter. So perhaps you know this guy on the screen. That's Walter, and it's first about entering a wall of pain. Some years ago, a developer told me, if you really like pain, please try out Cake PHP. Yeah. And 2 years ago, I had to write a feature for a monolith with Cake PHP. Honestly, Cake PHP it's really not a pleasure, because it was Cake PHP version 2.10. That's really old. But a wall of pain, if you're a real tough guy, try to use a Symfony Messenger as a transport. For me, one of the biggest components of Symfony, and it's coupled really deeply to the core of Symfony. You can do everything and nothing with it. The component is delivered with a lot of different transport. AMQP transport, Redis transport, Amazon SQS, and a lot of more. You need your own transport. That's not a problem. You can implement it really, really easily. I wrote an Azure Service Bus transport for our current project. Out of the box, the messenger can also handle retries and failures. That sounds, yeah, it sounds really great. So why I don't want to use it, or why I normally, yeah, not my preferred way to use the messenger component is, yeah, if you go with your truck to the bakery, then you are the right guy to use a Symfony Messenger, because the devil is really here in the details. Infrastructure tests are really a nightmare with this component. The configuration is wired deep into the Symfony core, so I wrote a lot of workarounds to set up an acceptable test case for infrastructure tests. Okay, let's go to the next transport. That's the adapter with the Symfony process. So, do you know this guy? Perhaps that's Elliot from the series Mr. Robot. It's a hacker, a genius, a really godlike man. It's really cool. Using the Symfony process feels, yeah, a little bit like Elliot has developed it, a lightweight alternative to the Symfony Messenger. You uphold the async barrier and minimize the inconsistency window. That's really cool. That's always my first choice of a transport. Of course, there's also negative side. You are not able to scale. Retry and failure handling are much more complicated than with the messenger. So, last slide before we go straight forward to the case study. Robert Lemke. I met Robert Lemke, I think 7 years ago in Switzerland. It was one of his first workshops about Flow 1.0. And it's a long time ago. And he told me that it took him around 2 weeks to implement property injection in Flow. Since I work with Symfony, I only use the constructor injection because Symfony normally use always the constructor injection. If you are going to look into the Neos event sourcing package, you will not find the flow property injection. That is, friendly speaking, really, really cool, because if you want to use a component standalone, the property injection it's a real pain. If I could have one wish, please don't couple Neos features too tightly to the framework, because then all the Symfony guy can use it, the Laravel guy can use it, and all the other PHP developer too. And that would be really, really great. So you had a lot of eventual consistency. I have here a small story about eventual consistency. Perhaps has anyone seen the movie The Big Lebowski? Perhaps the film is about the dude, back, easygoing burnout, mistaken for a millionaire of the same name. One of the main characters, Walter Subject, the main with the guy with a gun in his hand. A typical white American, he loves perhaps his gun more than anything else. The other guy with a bowling ball is called Jesus. And when the team of Jesus committed a rule violation, and to be honest, I didn't know that you can commit a rule violation in bowling, but it seems to be possible. Walter took out his gun and told them that they're entering a wall of pain now. We know that these two characters don't like each other, I think. So back to our problem, back to our screen. Be creative. What might happen in the situation? That you rolled a score of 1. The refugee, the girl on the top. So search for the cowboy, in our case, the protection. Before she found him at the bar, of course, because the cowboy is always in the bar, Yasus saw that the Jew finished his turn and asked the cowboy protection about the score. The cowboy told him the score for now. Yasso screamed out that his team won and so on and so forth. What exactly happened here? It took time for the refugee to find the cowboy. This period is known as the inconsistency window, and this time the score might be not up to date. The inconsistency window led to an unattractive situation. Hopefully, water is not your customer, right? Data can be stale. Stale doesn't mean inconsistent. It's just not exactly up to date. Being eventual constants allow a system to be scalable. Mind the gap. Try to minimize the inconsistency window. Talk to your customer. What is an acceptable inconsistency time for them? That's really important. So now I can start with a case study from our current project. So on our current project, we develop for a big international retail company. They own a container shipping app that handles the logistics between Europe, China, US, I already told it. And on the journey of a ship over the ocean, a lot of different milestones have to be reached. So load, you have to unload something, taxes, something like that. These milestones of a container were held in a graph. That's, in our case, a read model. On the screen, I took out 3 milestones of the graph. A sunny day on the sea, container arrived in Rotterdam, and containers unloaded. You see a simple direct graph with thumb edges. The milestone containers unloaded has 2 outgoing edges. We need these edges because we have to auto-resolve some milestones from time to time. So if the container is completely unloaded on the harbor, for example, then the unresolved milestone, a sunny day on the sea, it's not really possible anymore. So we have to auto-resolve this milestone. The auto-resolved milestone can also resolve other milestones. So you have more edges, and that's it. If we receive a container's unloaded event, it can end up in 3 different events. So far, so good. But yeah, what does this have to do with eventual consistency? Yeah, a lot. And you see in the next screen, we learned that eventual consistency leads to an inconsistency window. We also learned that we should minimize this window. But how can we avoid? That's really important. Unwanted results from a not exactly updated graph. The answer is really easy. You have to score the stream version in your read model. The 2 incoming events, container is unloaded and container arrived in Rotterdam, queried the graph projection and got beside a lot of properties, a stream version of 1 that you see in letter A. Afterwards, both events handle their tasks and eventual subtasks. Then container arrived in Rotterdam, finished earlier and committed to the store. That's letter B. The new stream version of the graph projection is 2 now. So that's easy. The other event, containers unloaded, tried to commit to the store, but ends up in an error. The event store checked against expected version and threw an error. So far, so good. Yeah, yeah, it's good, but not really. You have to think about what you want to do with a failed event. Perhaps you can throw it event back to a queue or try to process it later. But yeah, you have to think about that. So one more thing about catch-up subscriptions. In our case, we have a lot of different container streams. To be exact, I think it's more 100,000 different streams. Performance and scaling are really important for us, and of course, it's really important for everybody, not only for us. Out of the box, the catch-up subscription use the all stream. You can imagine how long a replay of all events will take with 100,000 containers. You want to go on holiday? Yeah, perhaps, but please start the replay first. But we want to replay only 1 container stream. So container 1 or container 2, whatever. If you look in the catch-up subscription again, there is a stream-aware listener interface that allows you to define an own static function, listens to stream. That's pretty cool, and you only have to implement the interface in your listener. What do you think? Can you replay one stream now? It's possible? Yeah, in my case or in our case, not really. Listens to stream method is static. Of course, you can use reflection or static property to pass in the correct container stream, but that leads to different problems in the applied events log. We are here at the conference at the moment. There's no better place to solve such issues. A lot of core developers are around for discussion, solutions, and many more. And I had already the discussion with Bastian Weidlich, and he told me that in the next release of the event store from Neos, I can do that. So that's really cool. Okay. Something here, you see, there's something to read. There are some books, and I'm really, really old, and so my preferred way is to read books. And here are some books about COQRS and versioning an event source system. But what I want to go here now is a little bit in. Hopefully, you see the local host at here now, because that's the demo, a small demo, and you see here blog comments and users. And if I go to users, you see here that that's me, and we can create a user, for example, here in the demo, like Neos conference, and then email neos@neos.io, for example, and then we create a user. So that's demo, and if you look now in PHP my admin, hopefully I know the password. Yeah, that's a typical that's an event store, and you see now we have here a user was created. We have here the metadata. We have the payload. We can look into the payload, and then you see okay in the payload with the ID, the name, the mail. We have here the different event stores. That's an event store with the block event store. Yeah, that's a possibility to play around with it, so that it's not only a talk and you're not able to test it. You see what happens here with events, and on the screen you can see here there's a screen. Okay, with only one event, this was user was created, but if you said okay, we want to add this Neos conference to Neos conference 2, for example, and update the user again, and now I would expect that we have now another event, and yes, here you have a user was updated event. So I think it's a good idea to play around with it a little bit, and that's it. Back to my presentation, and then I want to say thank you for this guys, especially Sebastian, because he developed the biggest part of the adapter. I want to thank Willem, because Willem is my English teacher since some years, and that's really a pain. And Thomas, that looks a little bit with me into the screens here. I want to say thank you that you listen to this talk, and hopefully you use the Symfony adapter in the future. If not, then hopefully you understand a little bit more about CQRS and event sourcing. And yeah, thank you very much, and open for questions, of course.
Thank you, Timo. Thank you very much. Yeah, event sourcing is a hard topic to get your head around, but I guess you explained it really well. So thanks again for that. And let's see if we have any questions from the audience.
There are no questions currently, but Timo already communicated his email address, and I think we can find you in the Neos Slack as well, if we have any more questions.
Yeah, I may have one question, because thinking about this eventual inconsistency, I was wondering how to mask it, right? So is there a common way or a common practice that you can mask this eventual inconsistency to the user?
Yeah, you can. That's a really hard topic. I don't mess it in a time frame, but what we have done is we've run Elasticsearch and we've around 1.5 million updates in our Elasticsearch index each day. And we do a CQRS pattern and we use Kubernetes. And what you can do, our customer said, oh, hey, come on, it took too long to update the Elastic index. So we run at the moment 5 apps in parallel to update the index. So of course you can mass and said, okay, if we have around too many updates, then we can mass it's too long to update the index, and then you can mass this, and then you can say, okay, we scale then the applications that updated this index. And we have not done it at the moment, but that's one of a big ticket in our company, that we scale it automatically, so that we say, okay, we look how long it takes to update, and if it takes too long because there are too many requests, then we scale it out of Kubernetes, and that's one big task at the moment.
Yeah, cool. Thanks a lot. And yeah, give a big applause once again for Timo Nussbaum.
Thank you.
So I'm really, it's really sad we can't give you your gin present, but I guess we will do this anytime later.
Yeah, and we also have 2
Yeah,
announcements.
I'm going to come to Dresden in 4 weeks, so.
So we'll cool
Cool.
it for you. Perfect.
Okay.
So we have 2 quick announcements to make. First up, if anybody wants to volunteer with dismantling this event afterwards, please come to the main backstage area before lunch. So I think there's some organizational stuff to take care of. And Eric has another announcement to make.
What was the second one, please?
The second one was the award winners.
Yeah. There's gonna be a photo on the main stage. So please, if you are a sponsor or if you are an award winner, please go there now, I guess, right?
Yep, before lunch.
So before lunch, and then there will be a photo taken from you.
Thank you very much. See you guys after lunch. Bye.
Bye-bye.
you it's gone way too far. No, nothing gonna help you when it falls apart. The prophets and the preachers told you, but you covered your ears, and now the end is near. Gonna tear it all down. 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 Call it revolution, call it whatever you need. Make a resolution, battle till you bleed. Prophets and the preachers warned you, but you waited too long, and now your chance is gone. Gonna tear it all down. 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 Burn down in the fire.
it up. Roll it up.
what day it is, but I know that I wanna spend it with you. One act so innocent, be careful to know that I'm telling the truth. Sorry, I made you love me. Sorry, you weren't one. Sorry, I made you love me. Sorry, I'm who you adore. I was just bored. Bored. I was just bored. Bored. I was just bored. No, I was bored. It's unambiguous. Promise I'm not trying to make you a fool. Promise I'm not trying to make you a fool. You just need some insurance. Your eyes fall out when I walk in a room. When I walk into a room. Sorry, I made you love me. Sorry, I'm who you adore. I know how bad you want it, but you're not getting more. I was just bored. I was just bored. Bored. I was just bored. I don't wanna watch you take it too far, and I don't wanna see you leave you a scar. I don't wanna watch you run away, run away, run away. Ugh, I'm so bored. I don't wanna see you. Sorry, you weren't one. I know how bad you want it, but you're not getting more. I was just bored. I was just bored. Bored. I was just bored. No, I was bored with you. No, I was bored. I know how bad you want it, bored.
I punch my card, I know what it costs. Yeah, I put in the work that you don't. Day after day, I work and I play. Yeah, I'll do all the things that you won't. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. Cause every time the push comes to shove, I'm climbing over you to reach the top. Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. Cause I want everything and nothing, 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 nothing at all. Don't care what you think or what you believe, cause I'm gonna turn the world upside down. If you want a shot, just step in the ring. Yeah, I'ma shake your bones like thunder. Even when my feet get tired, I will keep on moving higher. I'm the story you don't speak of. I'm the one they call the underdog. Cause every time the push comes to shove, I'm climbing over you to reach the top. Cause I want everything and nothing at all. Yeah, I want everything and nothing at all. Cause I want everything and nothing, 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 nothing at all. I don't want nothing at all, unless I can have it all. I don't want nothing, nothing at all. I don't want nothing at all, unless I can have it all. Nothing at all. want everything and nothing at all. 'Cause I want everything and nothing, 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 nothing at all. I don't want nothing at all, unless I can have it all. I don't want nothing at all, unless I can have it all. No, I don't want nothing at all, unless I can have it all. I don't want nothing at all, unless I can have it all. I don't want nothing at all, unless I can have it all. Anybody tell you it's gone way too far? No, nothing gonna help you when it falls apart. The prophets and the preachers told you, but you covered your ears, and now the end is near. Gonna tear it all down. 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 Call it revolution. Call it whatever you need. Make a resolution. till you bleed. Prophets and the preachers warned you, but you waited too long, and now your chance is gone. Gonna tear it all down. 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 Burn down in the fire. Let it all go down in flames. Let it all burn down in the fire. Let it all go down in flames. Let it all burn down in the fire. Let it all burn down in the fire. Let it all burn down in the fire. Ooh, let it all burn. Ooh, let it burn. Let it all burn
Okay, hi guys. It's been a pleasure to introduce the next talk. It's about common mistakes you do with database definitions, I guess. I don't know how many times I screwed up those. I guess the customers are in the other talk, but yeah, they still have open tickets because I missed some indices on database columns. Yeah, but anyways.
Yeah, unfortunately, Dejas Kumar can't be with us today, but he pre-recorded his talk, and we will just stream it here. And he's not available for questions afterwards, but if you have any further questions, we are very happy to relay them to him. And yeah, I think let's watch the talk. Have fun.
Let's get to it. So, hi, my name is Tejas. That's pronounced like advantageous. Whether or not I'm advantageous, we'll find out. And I am the director of developer relations at Zeta. At Zeta, we're just really trying to make databases easy. We're trying to give databases the love they deserve and give developers, web developers, the best developer experience they can possibly have with databases. That's like our whole thing. But that's not what we're here to talk about today. Today, we're here to talk about database complexity. And really, I'm excited for this. It's going to be maybe a bit longer, but let's see how we go. Before we get into it, I do want to talk about the motivation that went into this. And that motivation was supplied at a conference that I was recently at. I was recently at React Miami, shout out. And there was this amazing speaker. His name is Swix, or Sean Wang. He was the director of developer relations, so my job, but at a company called Temporal. And he had this amazing slide about full stack developers, a meme, if you will. And it essentially talked about how full stack developers usually are amazing on one side of the stack, but kind of okay on the other. I called myself a full stack developer. I'm no exception to this. And he had this amazing diagram of this beautiful front end and a so-so back end. Here, have a look. This is what it looks like. So this was his talk. It was a great talk. I think it's on YouTube. You should check it out. But look at this. That is a full stack developer, right? And I thought this was really funny. And that's really the motivation for this, right? Is some of us feel like imposters in the database space. Imposter syndrome is a real thing. Like, I hear a lot of people talking about like DynamoDB, Mongo Atlas, and SQL and schemaless, and like sometimes the imposter syndrome comes up. And here's what I'm here to say today. Let's fix this. Maybe this doesn't need to be the case. So what I'd like to talk about in our time together is 4 hard problems that databases experience that usually need to be solved anyway. And the hope is that I spend enough time talking about databases and these things using the terminology that we leave here with a bit more confidence in the area than we walked in with. That's really my goal. I will reference products. I'll probably use Redis and geek out at like, wow, how amazing is Redis? But that's secondary, okay? So with that, let's get into it. What are the top 4 problems we see in databases? Here, I'm just typing a bit. Right, so problems. Number 1 is analysis paralysis. What does that mean? It means we take way too long to do anything. And we try to be too careful, and then we end up doing nothing. And we'll dive deeper into some of these over time. But for now, analysis paralysis. It's kind of what it sounds like. Number 2, scale. How do you scale? How do you replicate? What does that mean? Should I use SQL? Should I use NoSQL? We'll talk about that. Number 3, data infrastructure. So it's not just about databases, but what we do with them. Oftentimes, databases need some type of caching, need some type of search engine. So there's a whole landscape that I think we deserve to talk about. And then 3rd is migrations. I feel like it would be, kind of an incomplete talk about database problems without mentioning migrations. Are probably the most problematic thing about databases. So with that, let's just break these down quickly and get straight into it. Thing number 1 is analysis paralysis. What does that mean? Analysis paralysis has a common understanding that you sometimes get way too nervous to do things, or you think way too much, and then you end up doing nothing. You get paralyzed by analyzing. This happens around a number of questions, two of which are, number one, do we go managed or self-hosted? Managed or self-hosted. We'll talk about what that means and the trade-offs between them. And number two, SQL or no SQL. Same thing. If you're not familiar with this, just stick around. We'll become comfortable. We'll talk about them. We'll understand a bit better. Let's start with managed or self-hosted. What does managed mean? Kind of what it sounds like. So a managed database is a database that somebody else owns, that essentially you rent and use for a fee. Most of the modern web, anyway, runs this way. Netflix stores a lot of stuff on other people's databases, as far as I know. A lot of the web runs on one particular cloud provider, that is Amazon Web Services or AWS, and like it's nuts. A lot of people pay them to rent their stuff. And so that is a managed database. Somebody else owns, creates, operates, maintains the database for you, and you pay them a little something. Usually what you pay them even is relative to your company's size and your usage. So if you use like 100 gigabytes, you pay for 100 gigabytes. If you use 1 kilobyte, you pay for 1 kilobyte. It's quite cool in that it can meet everybody where they're at. It's managed. Let's talk about the other one. Let's talk about self-hosted. What is self-hosted? The opposite of managed. Instead of somebody else hosting your stuff and you paying them, you do everything yourself. So let's talk about now the trade-offs between these two, the pros and cons. We'll start with managed. Number one, I mean, you save on hiring. Salaries are high. Maintenance costs are high. You save on like hiring a database administrator and so on. Like Amazon or Microsoft or any other company in the cloud has their own DBAs, database administrators. They pay them the salaries, and you just use a chunk of their work anyway, so you don't need to pay for that. You save on salaries. Number two, it's reliable and available. Like you sign an agreement usually, an agreement that it'll work the way you expect. They will service you within a certain amount of time, called an SLA. There's a lot of agreements you sign that say, hey, this is going to work reliably a certain percentage of the time. And if not, you can get a refund, you can get reimbursements, you can sue, like there's options, which is quite nice as a customer. Number three, variety. Like there's so many of these databases, managed databases around. I work for one, but there's Cosmos DB, DynamoDB, FaunaDB, EdgeDB, like there's tons, right? And it's really the choice of the person. Zada doesn't really have an opinion there. We think we give the best developer experience, but it's up to the people's choice. That's pretty cool. What are some cons of managed? Number one, less control, because it's somebody else's computer. Your thing is in somebody else's house. So you can't do whatever you want with it. You can't like go poke holes. You can't take it apart. You can't add more RAM when you want, physically anyway. You just have less control. It's not truly yours. Number two, privacy concerns. If I'm building like a medical app, and I store like how many stem cells people have, I don't even know if that's a thing, but like if I store sensitive data, even if they say they're not looking at it, there's no way to know. Maybe I'm just a conspiracy theorist. I don't know, but like I would feel much more comfortable about data privacy if I physically owned the thing in my house. So, that's I think something to be considered of. Number three, vendor lock-in. So, what that means is as you grow with something like AWS or Amazon Web Services and they host your database might get so big that you cannot break away from them and do your own thing. If you want to move from managed to self-hosted, it may prove really hard because it's just too big to move. Vendor lock-in is dangerous. And there's a lot of companies trying to mitigate this. Like at Zeta, we try to make it really easy to take your data somewhere else if you want, but not everybody. And so it's a real risk. Let's talk about self-hosted pros and cons. What is number one pro of self-hosted? More control. Like there's a difference between sleeping on your friend's couch and living on your friend's couch and living in your own house. You know what I'm saying? So with self-hosted, you're living in your own house. You can do whatever you want. It's the Wild West. You can just change the housing of your thing, like go nuts. It's pretty cool. Number two, bespoke security. It kind of ties into more control because you can do whatever you want, because you have this machine. You can add as many or as few security measures as you want. You can allocate other resources for other things. You can really do custom stuff, which is quite cool. Number 3, there is no lock-in. Like, what vendor are you going to lock in here yourself? Like, so it's quite nice to be free and not tied down to some for-profit capitalist machine. Cons: it is harder to scale. In Amazon Web Services, in AWS, I can say I want this machine to go from 8 gigabytes to 80 gigabytes. Click a button, it happens. Scale, at least vertical scale. If I want to add disk space to a physical machine I own, I need to take it apart, insert a disk. It's just harder. It's harder, and that's one of the trade-offs. Number 2, it's resource intensive. By resource, I mean, like, you know, every kind. It's going to consume your electricity. It's going to consume your energy. It's just expensive, and not the best for that. Number 3, I said expensive already, but it's also expensive in terms of money. Now, if you self-host, there's probably a good chance you're going to hire someone to do the job, right? And you have to pay them. Guess how much a database administrator earns? Too much. I'm just joking. But it's going to be more expensive if you self-host for sure because of that, and also then scaling and your costs. Those costs are bared by AWS and others in this case. So those are the trade-offs between SQL and NoSQL, between managed and self-host. I'm getting ahead of myself. But you might be thinking, what is my preference in this? What do I choose? I'm a bit biased, but my preference, as usual, is to go with managed because, look, if I grew up in Qatar, okay? If a light bulb was broken, I don't fix it myself. There's someone I can pay to do it. I know it sounds crass. It's the culture I grew up in. I'm not proud of it necessarily. It's just how it was. So any opportunity for me to pay for simplicity, I'll do it. But also, like, if there's a hackathon, okay, and I need to build like a Tinder clone in 10 hours, I would rather spend all the time working on my Twitter clone instead of like the first 6 hours figuring out, oh, it's a database machine. How do I set it up? How do I provision it? How do I scale it? Like, I don't care. I want to focus on my product and not on a database. So I would choose managed every single time. Let's move on. Next analysis paralysis question: SQL or NoSQL? This is not Shakespeare, by the way. This is just two technologies, and I need to clarify actually before we continue that they sound similar, but they are fundamentally different, and we'll get into it more over time. But before we get into the SQL or NoSQL debate, we need to consider another thing, which is called CAP theorem. It's CAP theorem. CAP theorem posits that you can have, by the way, CAP is an acronym for consistency, availability, partition, tolerance. And CAP theorem says you can have only 2 of them. So let's define the 3 of them and then look at why you can have only 2 of them. Okay. So let's start. Consistency. What does that mean? That means at any given time, your data is accurate. Consistency. Availability. At any given time, if I send a request for data, I get a response. I do not get a long wait time. I do not get a timeout. I do not get a failed request. Partition tolerance. So in a distributed system, meaning multiple computers, when a computer communicates with another and there's packet loss and the connection is interrupted, partition tolerance, that is called a partition, by the way, an interrupted connection between nodes. So partition tolerance means that even if something like that happens, the connection will work and I'll get my data. It tolerates the partition between systems, the severance in a connection, if you will. Okay. So CAP theorem says you can have 2 of them. Let's look at why and how that works. So let's assume we get just availability and partition tolerance. This is the setup for almost every big database in the world. Every big company that has scaled databases will have to settle for an AP CAP theorem style database because consistency is going to suffer. Let's examine this closely. So say you have partitions, meaning you have multiple computers. So you have a huge database at scale, right? Maybe it's SQL, maybe it's NoSQL, whatever, but your database is spread out across many servers, across many computers. Now, your database is going to receive a request for data, and that request might be routed to one computer in this cluster that does not have the latest data, but is under the lightest load. As a result, it will serve stale data. And there your consistency suffers. It's available, so it serves something. Any communication between nodes that goes wrong is going to succeed with partition tolerance, but your consistency will suffer. This is very common. Let's look at what happens if we don't have availability, but we have consistency and partition tolerance. So if the data is for sure consistent, and if communication between nodes works, what's going to happen is availability will suffer. Why? Because of something called replication lag. So as data is replicating across like hundreds of different computers, you have to wait for the data to be consistent across all of them. You have to wait for them to have consensus of accurate data. That delay means availability is not going to be immediate or even at all. In some cases, it might just time out because it's waiting too long, right? So that's how you don't get the availability piece. Lastly, let's look at how you don't have the partition. This to be fair, is quite rare, if I'm being honest, because like you always have, like to not have partition tolerance is to not have a distributed system. At least if I'm wrong, correct me. But how you can end up in a situation where you have consistency and availability, but no partition tolerance. Again, no partition tolerance meaning messages between computers, connections between computers are severed, and that's it. Your connection dies, right? How you can still have this is if you don't have multiple computers. Like if you have a very small one node SQL server, or NoSQL, whatever. If you have no partition, if you have no distributed systems, then you send a request. Data is going to be consistent because there is no replication and replication lag, and it's going to be available because it's a server. But you don't get partition tolerance because you don't have multiple nodes, right? So this is kind of how CAP theorem works, and this is important to understand as we talk about SQL or NoSQL, because by design these systems facilitate these things. What does that mean? Let's talk about it. So let's start with SQL. Now, what I want to do is talk about the trade-offs, the pros and cons with SQL. We'll start right off the bat. SQL gives you structure. Like SQL is opinionated. You need to have tables. Tables need to have columns, and columns have rows. Like that is structure. SQL also allows you to relate one table to another and say this field corresponds to that field and so on. SQL allows you a lot of structure. Number two, SQL gives you a familiar language of interacting with your data. I think many of us even learn SQL in school. Structured query language. I really hope the S stands for structured and not something else. Standardized query language. Anyway, it's a way to interact with your data. You can select, update, delete, insert. It's semantic and it's good, and it's more or less standardized and unified, such that if you work with any special flavor of SQL, Postgres, MySQL, whatever, you'll kind of find your sea legs. So it's quite valuable that way. Number three, ACID guarantees. Was that? We need to go down a bit deeper into a rabbit trail and talk about this. ACID. What is ACID? ACID is a backronym like CAP. It stands for atomicity, consistency, isolation, durability. These guarantees, you get them with a single SQL Server database. And let's talk briefly about what these are. Atomicity. Atomicity states that. So when you do stuff on a SQL Server, you do it through statements, SQL statements. Select star from something, that is a statement. A transaction is a collection of statements. Atomicity, the guarantee of atomicity states that in a given transaction, either all statements execute, and then the database is changed if there's an update, or none of them execute, and then nothing is changed. But in a scenario where like half of the statements work successfully and half don't, the transaction is rolled back and nothing is committed. And this gives you a lot of safety with these atomic transactions, right? Because you know then either something is going to work or something is not, but your database is never in some mixed Frankenstein state. That is an amazing guarantee for safety. Let's move on. Consistency. Consistency, we talked about it. At any given time, before a transaction, after a transaction, the data you get back is accurate. Number three, isolation. Transactions happen without knowledge of each other. So if you're a software engineer, you kind of have a cringy reaction to coupling. Systems should not couple. Why? Because then you break one, you break the other, right? It's similar with ACID. So when you do transactions, when you work with your SQL databases, you have the guarantee of isolation, meaning queries run separately and one will not affect the other. Again, it's a great safety measure. And lastly, durability. What that means is when a transaction is committed, then the data is persisted and always exists. And this is quite cool because the difference here is a difference to like a key value store or something that's in memory. When something is in memory, when you close the process or shut down your computer or something, the data is lost because it's in memory. It's not saved to a persistent medium like a disk. So durability says that when a transaction is committed, it's on disk and you can turn off your database and the data is still there and it will always be there until you decide to delete it. And even that delete transaction is going to be stored forever. So ACID guarantees. Hopefully we understand that now and we can come back and look at the pros and cons a bit more. So what are some cons of SQL? Number one, hardware costs. Expensive. Because with SQL, usually you have one server and then when it gets a lot of load, you scale it up. You're like, oh, I need more RAM. I need more disk space. I need to add a solid state drive. All of these hardware components are expensive. It would be much cheaper another way. Number two, normalization. What is normalization and why is it a con? I thought this was a good thing. Let's talk about that. So normalization, we'll talk about that after the next con, which is rigidity. My slides are weird. Whoa, something weird is happening. Look at that. Anyway, all right. Okay, rigidity was the last con. I'm not going back because it's too painful. But rigidity states that you have a rigid structure. Tables, column. We talked about this already. Structure and rigidity are kind of similar, but it's rigid and it's a con here because sometimes it's just easier. You don't know the structure of your data like from the get-go. You want to just say, I don't know, like I have a users table and I just have name and email. You don't know that you will need a photo URL until later. So that flexibility is not there. Instead, it's more of a con of rigidity. All right, back to the slides. Let's talk about normalization. What is normalization? Normalization is a way in which we can reduce redundancy, so repetition of data, and a way in which we can use data more intelligently in SQL databases to help us really get the most out of them. Normalization is standardized in what are called normal forms, abbreviated with NF, and there's 5 of them. So there's 1NF, first normal form, 2NF, second normal form, 3NF, third normal form, and of course, what do you think is next? Guess, what do you think? Of course what's next is BCNF 3.5 normal. Come on. Boyce Codd normal form, or 3.5 normal form, 4NF, fourth normal form, and 5NF. What do these mean? Look, we don't have as much time, so I probably won't get into the nitty-gritty of all of them, but I do want to highlight for sure the first normal form because it is the foundation. Like if your database doesn't comply to 1NF, you have problems. Okay, so let's spend some time on 1NF and we'll briefly touch on the others, but not too much. So what is 1NF? 1NF has some requirements. These requirements are, number one, cell values are atomic, meaning you have a single value in a cell, not like this, comma, that, comma, that, comma, that, okay? Number two, columns are strongly typed, meaning you can't have a column that has a number and text in it at different rows. It's weird. Number three, column names are distinct. Imagine a scenario where you forget to disambiguate. You have a table with 3 columns, name, email address, name. And one of the names is first name, the other name is last name, but you just chose because you like chaos. Column 1 is called name, email, and then name. You have 2 columns of the same name. Can you see how this would be problematic? So 1NF says, no, column names have to be different for sanity, for redundancy reduction as well. All right, number 4, order of data is irrelevant. And that is, if for your data to be 1NF, it doesn't need to be ordered. In fact, 1NF says embrace the unorderedness. Why? Because SQL has order by, where you can order stuff. It doesn't matter. Okay, so with that, let's now look at maybe a demo of this. I'd love to show you here on my screen what this looks like. So we have a table here. It's called bad table. And this table does not conform to any NF. So let's look at why. For starters, we have this favorite number. This type is sometimes a number, sometimes text. That's a bit weird. We can fix this by deleting the column, and we'll make another column, and we'll call it, this one is an integer column. It's not a string column. That's important, right? We'll call it favnum. John Favnum, great actor. And now we can do 1, 2, 3, 4. But look, notice if we try to enter some text here, there's validations. We're protected, and 1NF is kind of enforced, which is a good thing. Okay. Second problem with 1NF is this. Look, this is supposed to be atomic. Pets is supposed to have one value, but there's two. How can we fix this? What we can do is remove the collection here, and we'll just add another one with some of the same values. It's fine to have some of the same values because in the end, the whole row is not the same thing. So he had a snail, I believe. It's a reptile. 20 unread emails, and favorite number is 10. I don't know. So there. So now this actually does conform to 1NF. It's quite cool. Good. This is 1NF. Let's continue with the presentation. And what we'll see is, let me get my things in order. We'll see is this is 1NF. It's been defined already, so no definition there. But now we can see based on 1NF, all the other things follow. So 2NF, as we see here, is 1NF, but no partial dependency. What is a partial dependency? We need to come back to the laptop for this. So in a given database, in a given table, there's something called keys. A key is how you identify a given row. In this table, for example, this ID is what is called the primary key. You would, by ID, you would get and delete stuff by ID. You wouldn't like delete the row with name Tarun, because there could be like 50 Taruns here, then you delete everyone. So you use this one because it's a unique identifier and it is the primary key. So you delete the row with this ID instead. And this also helps then any related tables follow in a cascading delete and so on. Anyway, why am I telling you this? A dependency is a dependency on this, on the primary value. Or at least it should be. So name depends on ID. Email depends, all of these other columns depend on that one. That is a dependency. So what does 2NF mean with no partial dependency? Okay, so if now what you can have in SQL, what we just talked about, that ID column being the primary key, you can have a primary key with more than one column. You can say, let's go back to the laptop actually. You can say, instead of ID being the column, dream with me. Let's pretend our table looks like this, and name and email are a joined primary column. Okay, this table violates 2NF if, because of this this column here, unread email count. It is a partial dependency, meaning it depends only on the email address and not on the name. It doesn't care about the name. That partial dependency violates 2NF in this table. So how would we fix it? We would have a new table, emails, with an address, unread count, and we would link the user table, which this is, to the emails. We can actually maybe do that. So let's try to do that. So we'll create a new table. We'll call it emails, and what we'll do is we'll add some columns when the cold start happens, and we'll call this one. We'll call it, yeah, so this is an email here, and count, right, unread count. And what we'll do is we'll add a link to the first table, bad table, we'll call it user. Awesome. So now to implement 2NF, look, we have two tables. If we go back to bad table, we can actually delete this unread email count business. Delete the column. It's nonsensical values anyway. And we can even delete the email, but we'd have to create emails there. So let's just, for the demo's sake, we'll create just one. So we'll delete this column. Okay. And we'll add an email for me. So we'll add we'll say tejas@lol.com. Unread count is 250. And then we'll link my user here. Okay. So this now, if we go back to bad table, we should still be able to choose. I think I may need to reload the page. Actually, no, it doesn't have an email column, right? I can add a link column exactly to the email table, and I'll call this email, right? And this now properly implements 2NF. Email.email. We can, I think we can link this as well here. So now this properly implements 2NF. Anyway, back, we're spending too much time in this rabbit hole, I apologize. Back to the slide. What do we have? All right, so 3NF is the same as 2NF, but no transitive dependency. What is a transitive dependency? Well, okay, back to the laptop again. A transitive dependency is when a column doesn't depend on the primary key, but some other column. So in this case here, we have pet type. It really doesn't depend on the ID of the user, right? It depends on the pet. So again, this violates 3NF. How would we fix that? We would add a table called pets. Pets would have 2 columns, right? A pet name and a pet type, right? And then we would link bad table to pets. You kind of get the idea. So that's 3NF, but let's keep going. And again, I probably won't do all for the sake of time, but just to get you rolling. For example, BCNF is 3NF, but in a dependency, it's not primary to primary, but it's primary to always some secondary column. 4NF is BCNF, but there's no multi-value dependency, and 5NF is there's 4NF, but there's no join dependency. I think the join dependency in 5NF can be a bit complicated, so I will say this. A good way to test for 5NF is if you decompose your table into smaller tables, like we kind of just did, do you lose any meaningful information and relations? And if you do, you're violating 5NF. Okay, so with that, let's continue. What a bunch of rabbit trails. I love it. All right, let's talk about NoSQL. NoSQL has nothing to do with SQL. It's very different than SQL. In fact, you can query some NoSQL databases with SQL. It's just a different paradigm, and I see a lot of people treating like NoSQL as if it's like some variant of SQL. Big mistake. It's fundamentally different by design. So let's look at how. So NoSQL. On your left, you have what is a SQL database. It's usually one thing. On your right is what a NoSQL database looks like. A NoSQL database is usually always eventually spread across multiple servers, whereas a SQL database is usually one database per server. And with a SQL database, you can have replicas, but those would be separate servers too. It's very, like NoSQL by its design can be fragmented and partitioned much better. You might be thinking, why is that? Why does NoSQL get this privilege of spreading across multiple computers by design, and SQL doesn't? And it's because of rigidity and structure and normalization that NoSQL doesn't have. NoSQL databases are essentially key value stores. What does key value mean? A key is a name, an identifier, and a value is a value to that name. So for example, an example of a key value type object about me is the key is name, the value is Tejas, right? If we do a collection, the key is favorite food, the value is lettuce, comma, chicken, comma, whatever. It's a collection. So the key is something, and the value is the value of that something. Anyway, I hope that's helpful. But because it's just key value, and there's no like tables, columns, relationships, normalization, whatever, you can very easily scale them across multiple computers, even across thousands. In fact, if you look at this statistic here, Apple has a NoSQL database across about 75,000 plus servers. I think that is impressive. I think that's really impressive. One more note about normalization, why it was a con in the last slide, was because looking up stuff across linked tables and relationships and joins and stuff in SQL takes time. It's expensive, it's slow, therefore it's a con. Anyway, so back to NoSQL. Apple has a big amount of NoSQL servers for a database. And, like we talked about ACID guarantees with SQL, NoSQL has a complement. It's called base chemistry. You know what I'm saying? Base stands for, it's basically available, meaning it's always available more or less, but your consistency will vary. It uses soft state, meaning consistency is the state may not be accurate and it's eventually consistent. All three of these things in base mean the same thing. And that's a huge portion of NoSQL. Like, it's never accurate. It's all, maybe not all, never, but it's very rarely consistent with the latest state because writes keep happening to it really fast and replication is constantly happening. And you don't, it's very rare that you get the actual right number. Well, an example of NoSQL is probably something like Twitter like likes and retweets, these numbers, especially on like Elon Musk's account. Whatever you're seeing, by the time you see it, is outdated because he's that popular, right? So you always get inconsistent data, but this is a great use case for NoSQL. And if you use SQL for this, you're going to have a really hard time handling that load. Anyway, so that's base. Let's come back now and talk about pros and cons of NoSQL. NoSQL, I mean, the biggest pro by far is it's easily distributed. Because it's a key value store, you can like use something called a partition key that decides at what point does this split off into another server, does this database server split off into another, and you can, using this partition key, very intelligently segregate your data across hundreds, thousands of servers, and each one receives like segregated load, so it's not overwhelmed by like a bunch of load at once. It scales better, and I think that's a huge plus with NoSQL. Number two, the data is denormalized. Just like normalization was a con in SQL, denormalized data is a pro here. Why? Because there's no expensive lookups, there's no joins. These things take time. You don't have that in NoSQL, therefore it's faster. Number three, lower cost. It's much cheaper to buy like 50 slow or cheap machines and put different NoSQL partitions on it instead of buying like one super powerful computer, right? So, or multiple super powerful computers. So because of that, it's actually much cheaper. All right. Cons, there is no standard language. Like SQL is beautiful, but NoSQL is the Wild West. Like you would use some query language in one NoSQL style database in Mongo, for example. In Cassandra, you'd use another. Collection means something in some languages, document. So it's not standardized and it can be hard to navigate. Number two, the data is inconsistent often by design. You're just going to have to deal with that. But if it's something like retweet counts and like counts, doesn't really matter. Again, it's about picking the right tool for the job. And third, joins and relations. So if you have kind of like we just did, like users and email addresses, if you have two tables, in SQL, you can relate them by design. That's what SQL databases were made for. In NoSQL, you'd have to get a user and then take their ID and then go to your emails collection somewhere and find an email where the user ID, like it's complicated. And the database itself doesn't help you make this connection. You would have to know how to code in some language, JavaScript, TypeScript, Go, Rust, something to glue stuff together. And that's, I feel like, a con, because ideally it just gives you this out of the box. All right, that was the first of 4 problems. I know. It's been a while. It's been quite a long time, but let's keep going and see if we can still, do good here. Let's move on to number 2. Number 2 is replication. Replication is important at any level of scale. Why? Because at some point your one server is going to be overwhelmed. Like if you get really popular, I mean, think of YouTube, Twitter, Reddit, Instagram, like everybody replicates at some point. You have to. You can replicate SQL and NoSQL, and that's kind of exactly what we're going to talk about. We will spend more time on SQL replication because it's a bit more involved. With SQL replication, how it typically works is you have a main database and multiple replicas. Most applications tend to be read heavy, not all, but read heavy, meaning you read a lot. Like you have millions of people opening Instagram and looking at photos, and you have fewer people posting, usually. A lot of people browse, fewer people post. So for read heavy things, what you'll have is one main primary database where you send your write operations to save data, and then like an army, like 50 plus even more replicas that are responsible for reading that you can load balance between. You can send reads to the one that's under the least amount of load, for example. So a primary and multiple read replicas is quite the common model. There's multiple ways to do this though. And what I'm about to do is break down some of the ways of replication in SQL, but some are specific to specific databases, like some will only be on MySQL, some will only be on Postgres. We'll try not to get into those details, but just kind of break down some of these, because chances are you've heard these words somewhere and maybe you didn't get them. So the goal of this whole thing is to eliminate imposter syndrome anyway. So with that, let's go for it. So SQL replication. First kind of replication I've heard of is called statement replication. Statement replication, how it works is you send a write, or you send any operation to your primary database, and what it'll do is it will send the exact same SQL statement to the replica, which I think may not be ideal. And it may not be ideal because the statements are usually expensive to run. Like, your chances are you're doing stuff, and you're going to run them on your primary, and then like your replicas are going to run them too. And your replicas may not be as powerful, and so you may have problems. You just don't want to run stuff twice on different machines. So statement-based, not so much for me. What else do we got? Binary replication. Now we're kind of talking, because what binary replication entails is your primary gets a statement, executes a statement, gets the binary output for the statement, and then sends that to replicas. So the replicas don't do any executing of statements. They take the output and apply them, right? This is awesome. But the drawback I've seen, maybe version mismatches. For example, if your primary is like Postgres 14 and you have some replicas, Postgres 12, Postgres 10, I don't know, binary output can differ, and then you run into consistency problems and maybe others. So not the best. But then there's also logical replication, and I think this is the best. You can even do this in a streamed way. But how it works is, I think this is also exclusive to Postgres, correct me if I'm wrong, but it's the same as binary, except it's wrapped with a bit more logic that can transcend version mismatches. And it's essentially the statement is executed, some logic is generated or exists, and it's applied across the replicas. It's quite cool. In a sense, you could say, the primary, in an oversimplified sense, you could say the primary says to the replicas, hey, someone changed X to Y. Change X to Y. So it's instructions essentially that are streamed from somewhere. All right, and then synchronous. If we go back to CAP theorem, consistency, availability, partition tolerance, and maybe availability isn't so important to you, but consistency is, and partition tolerance. In this setup, this is what synchronous replication will do. How it works is your primary will receive a write, but it will not commit the write. It will then send this write to replicas and get an okay from them. Yes, I've written it, I've written it, I've written it, I've written it. And when all the replicas follow, the primary will commit and you'll get an okay. And this is great because then you're guaranteed consistency. You're guaranteed that all the replicas and the primary are in the same place and you're good. This is very good for like financial apps and things where consistency is important. Lastly, bidirectional replication. I think this is the worst. The assumption here is you have not one main write database, but multiple. And generally, when you accept multiple writes anywhere, anytime, you're probably going to have a bad time because conflict resolution, right? Like if you think about Google Docs, you have like 5 people editing something and the internet connections are not so stable, like you might have someone delete something that someone just wrote. That's bidirectional replication gives you these problems, which I just like, why? I don't really want that. Anyway, that's SQL replication, but let's talk about NoSQL replication. Look, by design, it's kind of the same. You have the model of primary and multiple nodes in NoSQL, same way. And it actually maybe works better in NoSQL because it can be segregated like that more easily. But you also have some NoSQL databases that would, you can send a write to any node, and they would reconcile the state within themselves. It's quite cool. But effectively, for all intents and purposes, it's similar, if not the same. All right, let's talk about the next problem, the third one, which is data infrastructure. Data infrastructure. Now, across any org, it's not just databases usually. There's a lot more. And I think the best way to illustrate this is through a nice diagram. So if you'll come with me to the laptop, we're going to use an amazing tool that I like. It's called Excalidraw. And I just want to model for you conversations I've had over and over and over again. And I've seen companies do this. So you start out with a database, whatever it may be, SQL, NoSQL, whatever. You scale it up as you grow. You're like, okay, more RAM, more disk. Then you scale it horizontally. You add more databases, right? And yeah, this is cool. And it works for a while. Everything's fine. But then you start to realize, oh, it's a bit slow. And it's a bit slow usually because you're reading from and writing to disk. So you think, okay, what can we do? Well, random access memory, RAM, is faster by design. So maybe we can take some of the data that users need quickly and put it in RAM. This is literally how computers work as well. So we'll take some of that and put it in RAM so that when people access it, they get it from RAM and it's super fast. And this is also how Twitter works. That's how it's so fast when you get tweets and stuff. So let's look at that. So it looks like this. So you'll use some RAM-based situation. And how it works is your app will ask the RAM-based stuff for information in itself, in its cache, if it has any. If it has it, it gives it to the app instantly. This is called a cache hit. But if it's cache miss, meaning if it asks our RAM-based thing, let's, what's happening here? Let's call RAM-based thing Redis. Why not? So if Redis doesn't have it, then it's a cache miss. It's going to ask the database for the data, get it, store it, send it back. This will take a bit more time, but only once. That's quite cool. I need to pause here and tell you that Redis is amazing. Like, I see a lot of people using Redis just as a cache. It is so much more than a cache. Like, Redis is a full-fledged database and a pub sub engine. Man, I think we should do a demo here. Let's be quick, I promise. So look, I'm just so fascinated by this. So if we go to the terminal and we'll do docker run name Tejas port. I don't, is it 6? What is Redis default port? 6379. 6379 from my computer to 6379 in the image. And I'll just do Redis. Oops. Oh, really? It's -p? Okay. What? Port is already allocated. Am I running Redis already? Oh, okay. Let's kill that one. Let's try this again. What? Container name Tejas is already in use? Fabienne, I don't know. Cool. So it's running. It's ready to accept connections. Now, it's okay. Let's go here at Docker. What is it? Exec interactive terminal, I think. And we'll do Redis and we'll run Redis CLI. I think this is all I need. No, right? It's called Fabienne, of course. Okay, so I'm in Redis now, and I can easily like set thing to hello, right? And it's set. It's okay. So if I get thing, it's hello. But the cool thing is, if I kill Redis, if I just go like docker stop Fabienne, right? It stopped it, and if I go here, look at this. DB saved on disk. Oof! Like Redis is a database. Like it has durability. And so, I mean, if I do docker start Fabienne, and if I run my same docker, if I go to the CLI, if I get thing, it's still there. What? So that's cool. And also, I can do other stuff. I can do pub sub. I can literally do pub sub. So I can, I will subscribe to a channel, subscribe to, I don't know, Tejas or Tage. So now I'm subscribed to this channel. And then in another Redis, I can, where is it? Let's do docker exec. Again, same thing. TI, Fabienne, Redis, CLI. Right, so if I come here, I can actually publish to the channel Tage sup. And one means true, and look, I subscribed and I got it. Redis is kind of nuts. Anyway, I got reminded of Redis from this. Anyway, back to the data infrastructure. So you have a database, you have replicas, you have Redis. But as you grow, you're going to grow so big that you're going to need some way to what? To search. Every big thing in the world has search. I mean, Google, Twitter, Instagram, Reddit. So you're going to need search. So if we go back here, how do we do that? Let's say we have some type of search, maybe Elasticsearch. And what we'll do is we'll need some way now to replicate the database from the database, or the data rather, from the database to the search engine. So we can talk to the search. A search engine essentially is a document store as well, right? That's optimized for like relevancy and typo tolerance and stuff like that. So we'll need a way to replicate data from the database to the search engine. Usually this is done with something called Kafka. Kafka is a stream processor by Apache. So your database will send data here, which will process the queue, the streaming queue, and send it here, and then everything's fine. All of these are distributed as well, right? So anyway, you get the idea. So this is also distributed. Everything's distributed. Just assume that. Okay, so that's the design, and this looks complicated. Like, imagine everybody having to set this up all the time. Data infrastructure is hard. This is why Zata exists. Like this thing I just showed you, this design here, this design is Zata under the hood, more or less. It's maybe a bit simplified. We do a bit more, but generally that's it. And so, like, if you want to talk about search, we actually have, like, we use the search engine in our own docs. If you go to docs.zata.io, like, you do the search. Let's quickly move on. I think we're over time. So if we go back to the slide deck, data infrastructure was hard. Last slide, fourth problem, migrations. Migrations are super hard database-wise. Why? Because with migrations, you don't know, oftentimes you don't know a lot. You don't know where to store them, Git repo, cloud, somewhere. You don't know where to run them, how to test them. How do you deploy them without much downtime, without a migration window? The cost of messing up a migration is a cost that sometimes is way too high to bear. And so, yeah, we need to really be careful around migrations. I don't yet know the best way to do it. I'm sure there's many good ways, but this is also what we're trying to solve with Zata. And I can show you that if you're interested. So if we come back to the laptop, we can even do a migration probably on our table here. So if we come back to the laptop, this table, the bad table, the bad database, let's try and do something there. So what we're going to do is go back here. Actually, do we want to? Yeah, let's go back here. And we have something that changed. Let's just rmrf Zata. I think this is from some stale thing. Status, yeah, okay. Clean F. Okay. You know what, let's just, okay. So now we'll init another Git repository. And we have a main branch already. That's cool. What we'll run is we'll run Zata init. And do you want to create a new database? No, I want to use 1NF. So I have this, and I'm done. I literally have, if I open code, I have this database now locally with my bad table, with all the stuff as code. It's pretty nice. But I noticed my bad table is quite bad because it doesn't allow people to have pronouns. So I can check out a new branch. Let's call it pro. And what we'll do is we will Zata deploy, just to deploy this branch. Okay, the schema is up to date, never mind. So we'll change the schema. We'll say we have a pronouns, and it's a string. And now if we do Zata deploy, it's asking me, do I want to add the column pronouns? Yes, I do. Great, I did a migration. I think I should see it if I refresh. I don't see it. Oh, I do see it, right, pronouns. This is great. I'm going to commit this. Zata is seeing this as my default branch because I haven't really committed anything yet. It's fine, it's my mistake, but let's make a new branch now and call it avatar. New branch. Let's add, instead of pronouns, we'll add avatar URL as a string. Zata deploy. Now that I have a new branch, database 1NF doesn't have a branch avatar. Would you like to start a new branch? Yeah. From which branch should I fork the new branch? Main. So now it's forking this branch, and it's now giving me a plan. Do you want to add column avatar URL? Yeah, I do. Done. So now if I come back here, I have a new branch avatar, and if I am in the bad table, notice the data, we had some data, right? If I go back to the main, there is some data. We don't copy data between branches for privacy. So we do have this table, and if we look at avatar, we do have avatar URL here in this branch, but not in main. At least hopefully not. Yeah, we don't. So we can evolve our schema this way in a safe way where the data is not copied and everything's cool. And in fact, I can even Zata random data for the table bad table. And it'll actually insert data here in this branch only to show me that this looks like a string. And I'm happy. And of course, the data is not shared between branches, so we're all good. And at some point, I can open a migration request. My team reviews it just like GitHub, merge, and then it goes to production safely. The migration that is run is a rolling deployment, meaning if we receive a query for the old schema, we translate it in real time to the new thing and apply it. It's rolling, and it's also zero downtime, meaning there is no like 503 service unavailable. It just works. Migrations are super hard, and I haven't found an easy way to do them yet. That's kind of why I helped make this thing. But let's get back to the presentation. So let's talk takeaways. What do I want you to leave with today? Number one, databases are hard and really are not to be underestimated. I think that's super important. Wow, my slides are not having it today. Okay, there. Databases are hard. There's a lot of complexity, and it's very easy to get wrong. Like, for example, in a NoSQL setup, if you set the wrong partition key, you have like 50 nodes with different partition keys, and some nodes are way too oversaturated and others are not. It's very hard to change. And really, if you're building like an app like YouTube about videos, you shouldn't have to deal with this. You should just focus on something that helps you upload videos. You know what I'm saying? Next topic. There are always trade-offs. We get way too religious in the tech industry. Some people say, oh, I only use NoSQL, or others say, I only use Postgres and not MySQL, and Vitesse is the worst. And like, no, all the tools, like even if they're, like especially because they're open source, in my opinion, all open source tools are a blessing. They're a free gift that someone gives. My goodness. And really, there's trade-offs. I can tell you ways Zata is just not good. I can tell you ways Postgres is quite nice and ways that it's not. Like everything has trade-offs. One is not inherently better than the other, but it's about picking the right tool for the job. And number three, with databases, safety is key. You really cannot afford to screw up a database because the worst case, you lose data. Can you imagine showing up to like Instagram one day and your account just doesn't exist because someone was negligent and made a mistake? But it has photos of mine from like 15 years. I know. You want to be as safe as possible. And sometimes that means moving slow. But generally with databases, the safer you are, the better you are. And so I would encourage navigating these complex problems with a little bit of safety in order to create great databases and scale them well. With that, I want to say thank you so much for enduring. I know it's been long. I hope this has been helpful, and catch you again soon in the next one. Peace.
So this was a very in-depth talk by Tejas, and if you have any further questions, you can contact him. He put on the information on the last slide there on Twitter or GitHub. So Eric, what's next?
Next is Bernhard Schmidt with the talk about Fusion and component APIs and how to enforce them. Personally, for me, this is my most interested talk, I guess, for the day. So I'm looking very forward to it. Yeah, and we are a bit over time, so please make a short break if possible. And yeah, in 10 minutes, we will be hearing Bernhard.
All right. The break was actually a bit shorter than intended because we're running a bit late on this stage. And yeah, so for the next talk, I like to welcome Bernhard Schmidt onto the stage. And he's going to talk about component APIs and how to enforce them. So big round of applause for Bernhard, please.
Yep. So hello, fellow Neosians, and welcome to my little talk about components, their APIs, and why component APIs are so important. I'm Bernhard. In the Neos community, I mostly work on the event-sourced content repository, and especially the Postgres hypergraph projection. But mainly, I, of course, work at Zeitgeist as software architect and backend developer. So as you might know, most of the time, I don't work on Neos, but with Neos, just like all of you. Which brings us to our topic today, which is our beloved presentation layer, Fusion. Or as I would say, the most sophisticated way to cast node interface to string that we currently have. So what is Fusion? I mean, you know it. Probably I want to point out a few things that are interesting for our architecture here. So Fusion is designed as some kind of glue code layer between domain and presentation. Domain being mostly on node types, which define the semantics, and presentation, which is the HTML markup you have in your AFX, for example. It's component-based. That's extremely helpful, especially for this case here. And it's already a great advantage over other templating engines we had in the past. That's what's really great about Fusion. So it's by design as declarative as possible. So what you mainly try to do is map something like key to value, and be done with it. It's extremely flexible. So, for example, if you write a component, then you don't have to declare anything. So basically, you just pass around arrays of stuff, and imagine you would just shuffle all components all over the place, and Fusion would still work and render something. Most probably nothing sensible, but it would still work. It has AOP-style prototype override, so any package can override any other package's prototypes, which is extremely powerful, but also extremely dangerous. It can implement logic via EEL helpers. Those can range from easy date formatting, for example, to complex queries to Elasticsearch, for example. And we have flow query, which is a kind of query builder that's usually used to query nodes. And there we have, one thing that I want to say is that maybe if your glue code layer starts querying all over the place, something might be off already. The language itself is closely modeled after front-end technologies. So you have flow query, which is similar to jQuery. The React prop types made it into the code base as Fusion prop types. And we have something similar to JSX, which is AFX. So any issues with that? What's not to like about this? I've brought one simple component with me. It's basically component 0, because I had some issues with that component. What I did was I used this somewhere in the integration code. I used an image, and that's basically what it does. It renders an image. And I set the width to some value, and it didn't work. And so I looked at the source code. Is there something wrong in Kaleidoscope? Is there anything wrong in the media library for Neos, and so on? And after like half an hour of searching the code, what I found is that 3 layers upwards in another component, I had a typo in the word width, which isn't that hard to do because, I mean, width and height, they are words that scream, please put a typo in me. So, and there's another thing. There is props.class, right? This isn't declared above. And yeah, passing classes as props isn't really that good of an API either, because as an integrator, what I'm supposed to put in there? So the issue with arrays, right? Because that's our problem, we pass around arrays. So we don't have any guarantee what's in there, right? I mean, did I provide all the props that are necessary to properly render this component? Did I make any typos? What type is actually required for each prop? And what props are available anyway? I don't know that. I have to look in the rendering, actually. And all these problems cascade through at apply. That's what happened in my case. I defined some props, then I applied that to the next child component, and then it was applied to the next child component, and somewhere else in the rendering an error occurred. We don't have any IDE support for that, so if you want to add, you want to render a component, you pass the parameters, you have to basically guess what parameters there are, you have to look up in the API and so on. There's currently no possibility to statically analyze this, so if anything goes wrong, you'll notice this when you render it, not before. And so in general, arrays just don't make good API specifications. So as always in the Neos rendering layer, what would JavaScript do in our case? I mean, most probably I haven't been the first person to run into this kind of issue. What happens are prop types. That's a JavaScript concept. So you can declare the actual props of this component with type, are they required, and you can set it to strict mode, which will just throw an error if you put anything else in. So we have a separate declaration of props, or basically the default values, and the prop types. We have runtime validation in, if something's the wrong type or not given, at least in the rendering, we get an error. And we are not prone to parameter typos in strict mode because of runtime exceptions. So in my case, that would already have helped because it would have said width or whatever way I wrote it wasn't part of the API. You're still prone to prop call typos. So if in your rendering you have a typo, it still will be reserved to empty string. And we still have no static analysis. So it basically states that there's something wrong, but it still doesn't say where you did it wrong. Because basically we're still arrays. And at that moment in time, I was already slightly annoyed. I found out that this array thing was our basic problem. And I was like, okay, when writing the Neos core and especially the content repository, we have value objects and the like all over the place, so nothing can go wrong. And in my day job, I'm supposed to juggle around arrays? I don't think so. So what can we do? What happened next in JavaScript, because you know what would JavaScript do, was TypeScript. So they had actually a type-safe language with objects and so on. And it's highly favored over prop types. And basically, as I heard, I mean, I'm a backend developer, no one uses prop types when you have TypeScript. So what do we do next? Type fusion. But before we start talking about that, I'd like to take a step back. Because, I mean, if only we had a language, right, that adds type safety, static analysis, a wide range of IDE support and tooling in general, no maintenance to be done on our side, and that is already part of our Neos ecosystem, that would be great, right? So let's talk about the elephant in the room and how to address this properly. So, I mean, we can, of course, use PHP a lot for this, but we don't want to just throw PHP at the problem. So let's have a short look at what we actually need for this. And our goal is build magnetic puzzle pieces. I mean, you saw that Azure puzzle at the beginning of the presentation. That's really nice in your free time, but you don't want to do something like that if time is of the essence, right? So what is a component actually? So it's replaceable. That's the main feature of components, right? So if you don't like it anymore, or if you got a different specification, just throw it away, build a new one. Isolated. So for example, a presentational component must never call some parent component or a node or something. It just has to be context independent, right? So they define an API. That's important for replaceability, because if you replace something, it would be nice what you need to provide in the new implementation. And also, yeah, that's nice for analysis later. We have integrational versus presentational components, where the integrational are doing the mapping stuff and the presentational components just render stuff. And some special features of presentational components, so they are stupid. They don't have any logic besides some presentational stuff. And they should be reusable across semantic contexts, right? So for example, if you render that kind of teaser card, it doesn't really matter if there's a product or a blog posting rendered here, right? So it can be used for both. Integration. That's one thing we have to look at. So what is integration? So basically we have semantics on the one hand, which might be some kind of blog posting node type, or it might be a product entity coming from a web service or whatever. Then we have presentational components that might be such a card with an image and headline and text, Or it might be a stage at the beginning of the page with that big image and some headline and so on. Then we have integration, which says, okay, I have this entity and I want to map it to a component. And so semantics and presentation are completely distinct, right? So a blog posting, for example, can be rendered either as a card or as a stage, while the card might be rendered using a blog posting or a web page. So if you want to describe integration, so what is it? So actually it's a function, right? You pass an entity in and you get a component out. It should contain all the logic, right? So from querying stuff to formatting dates and so on, this should all happen in the integration part. It's deterministic. That's really interesting. So the moment you have a document node, you already know which components are to be rendered. There's no magic happening after that. Components, especially presentational components, should expect the data exactly as they need it, right? So that's the API. What's the API is for? The headline should be a string, right? No reason to put an image there. So we need a declaration of a strict component API so that we can be safe that the component gets all it needs. And there is no such thing as a presentational logic except for conditions. I mean, you want that at if, for example, loops, delegation to child components, and string concatenation. And everything else should actually happen in the integration part. And especially there are no domain entities involved anymore, especially no nodes, right? If you use your node in your presentational component, then the presentational component depends on this node being there, and it's no longer a presentational component. So what can we do? We want something type safe, and we want to enforce this. So we built a PHP class. That's basically a very plain PHP object. Here in our example, we use 8.1, which makes this class a lot, let's say it fits on the screen, right? Because otherwise you would have all these properties and the large constructor and all the getters, and that's all gone in 8.1. They complement, or better, they replace props, right? Instead of a props array, you now have this object. So it's type safe, you can statically analyze it, you can unit test it, whatever you want. And it may only be composed of primitives, enums now in 8.1, for example, for variants instead of this class interface, right? Other components, and slots, which is a concept I'll come to later. They should be immutable, because once I created this thing, no one else should be able to manipulate it as it is passed from component to component. And it cannot be called. That's a feature of this abstract component presentation object. So if you do something like props.something and there's a typo, and then EEL will try to call this object if there is any magic function there, and if this doesn't return anything, then EEL will just default to empty string. So if we override this call method, which I did, and just throw an invalid argument exception, then you have actual type safety even when you call props.something. So we have this object. So what does the component look like? It's basically, the rendering is basically very similar, right? We have a variant instead of this class attribute. But besides of that, we just do presentation object dot something instead of props dot something. All the API configuration or declaration is actually in the PHP object. So thanks to Christian Vette's plugin, you just can click on the PHP class and you're there, and all the types and prop names are readily available. So yeah, you can just do that. What's important is that you have to declare this class, right? This PHP class, it has to exist. And if you want to render this thing, this object has to be passed as a variable. If this object isn't there or the object is not of the right type, it will throw a runtime error. Yeah, we had that with the core stuff. And as you see, there are no special Fusion features in here, right? No this, no add context, no add process, or whatever. because, as already stated, this component needs all its data already readily available. So this component API is enforced. So I really, it was rather hard to find a perspective from which this cute little PHP elephant looks intimidating. That's the best I came up with. So we still somehow have to instantiate this object, right? And you can't create a PHP object in Fusion. At least you could not until the day before yesterday, when Martin published the Zeitgeist Rollup package. Now in PHP 8 you can, but before that, and for other special cases, or most cases, I guess, you have to write some kind of factory, right? And this factory is actually the function I talked about earlier. You get some parameters, a node and are we in the backend or not, and we return the figure, which is our presentation object. We need to render the component. So now we just we check, do we have an image? If yes, use an asset image source from the Kaleidoscope. If not, and we are in the backend, then use a dummy image source. And if that's still not the case, then, for example, throw an exception, do something else, whatever you like. Then we return the object, and you're done. So the character of this is actually functional. I mean, it's a factory class in Flow because we need dependency injection for some things. But the idea is that it's just parameter in, parameter out. We have variables. I mean, it's PHP, of course, we have them. If you tried this in Fusion with this and add context and the combination of this and context, you will soon see that this gets problematic all of the time. So having actual variables is really, really great. This is statically analyzable, right? If you do anything wrong here, I mean, you can't possibly do typos, but if you do something syntactically wrong, then your IDE will scream in your face, and if you use a regular text editor, at least PHP Stan will scream in your face. And it's actually quite easily testable with PHP unit, right? It's just node in, something out. So what does the integration component look like? It's just basically, yeah, we have, it's a content component because we want the wrapping. Then we render our presentational component and assign a presentation object that we create with this factory, which is registered as an EEL helper. So we have direct delegation to the component. Nothing else is happening here, and all logic happens in the factory. So this was basically the release of presentation objects 1. So let's have a quick look at this. So we have a rather verbose code base actually, because PHP 7.3 was the thing to go back then. With all these large classes, we also had interfaces for that and so on. We could eliminate complete classes of errors, right? You can't do anything wrong in integration. I mean, you can of course use the wrong component, for example, but that is something you don't do by accident. Yeah, we have a language switch, which is rather nasty. I mean, you start in Fusion, then you switch to PHP, which renders the component or creates the object, and then we go back to Fusion and render it. That's not so nice. If we look at the integration, it's always the same pattern, right? You have the content component, and you just render one presentation component, and you're done. And this is created by the factory, and this pattern is all over the place for all your integration components. So we have to wrap some things like cache or wrapping for editables. We had to do this manually. That wasn't nice either. And which leads me to the next point. How to do editable in PHP components. So the original problem is, I mean, we can't have nodes as properties in our components, right? Because now we do not want that. But how do we do a content element wrapping without a node? That doesn't work, right? So the first thing we tried is we have self-wrapping components where we assign some function containing that node, which could then wrap, could be applied with a process wrap and just apply the function. And it kind of worked, but it wasn't nice either. Then Wilhelm came up with an idea, and this idea is slots. So what is a slot? So it's basically just a Fusion prototype, and you have to assign it a presentation object of type slot, which basically means it has to have two properties, right? It has to define which prototype is to be rendered. So and it has to implement the interface required by that prototype. So you can encapsulate basically everything. So what kind of slot types have we? We have value, which is basically a glorified string, right? Here is a string you just render as a value slot. Then you have editable, and this is getting interesting. Editable needs a node, a property name, and then can be put into a slot. And it's interchangeable with value, for example, right? So you have a presentational component, like a text, for example, and the actual text content is a slot, and you can put in either value, for example, if it doesn't come from a node, but from a label, for example, or you put in editable if it's an editable node property, and you can still use the same component. We have the content slot for nodes, and this will just be then again delegated to content case. We have a collection for iterables, so you can also put an array of slots in there. And in version 4, there will be cache segments, but you can implement them today as well. And one thing that's interesting, that's the second exclamation mark here, all presentation objects know their prototype name because the prototype name in Fusion can be translated to the PHP object's fully qualified name, and vice versa. This is our example, right? We have this text component with some wrapping div, and then we just render the slot, which can be either editable or just a plain value. The object would be just a class text, which just has this slot interface as content property. And here, for example, we have the factory, right? So we can have a value slot for some, let's say, the manufacturer part number from a product, or we can have an editable slot for blog postings headline, for example. So consequences for integration. We already know that integration components, they just delegate stuff to their presentational component, and slots accept any presentation object. So can we combine this? Yes, we can. So we say goodbye to integration components and say hello to the content slot factory. So what do we have to do? We just take the content collection renderer, right? Because this does this case stuff and then renders a prototype that matches the node type name. And we just say, okay, we always know this must be a content component for the wrapping. And inside that content component, as we already found out, we just need a slot, right? And in that slot, we put any presentation object this content slot factory creates for the given node. You just have to declare this once. And from then on, no more integrational components, but just let's say a root factory like this, right? You just get the content node in, and there you have the switch case, switch presentation object to create. Yeah, exactly. So for a text node, we create a text. For an image node, we create a figure, for example. We can use the figure factory from before, for example. No problem here. And then you're done. So observations. So integration now can be done type safe, statically analyzable, and testable, right? It's all in plain, simple PHP. We still have two blind spots. A node get property is an issue because we don't know what's in there, because properties of a node are an array. Presentation object.prop is still a problem because it cannot be statically analyzable, right? It will throw a runtime error if you type something wrong, but you will still not know before rendering. You can actually debug your stuff via var dump. That's really, really nice because you can just do that in your factory. You can still have resource collocation with PSR4, so your PHP file will reside directly next to your Fusion file. Refactoring is a little bit more complex, but it's also safe. So, before you could just say, okay, I use another prop in my rendering and you're done, and if there's nothing given provided, then empty string, right? But now you have to extend this. You have to add another property to the PHP class, and then you have to look. So, okay, where is this instantiated? And but in this way, you won't miss any spot where to put data in, right? And if you missed such a spot, PHP stand will notify you, right? So here's a missing parameter, and then you can think about, okay, this new prop of the presentation object, what do I put in this case? So factories provide an index, right? So you, if, for example, if you have a figure factory, then you can see, okay, these are all the cases where figures are instantiated. That's really nice. And we still have the language switch, right? But we have one switch less. So we start integration basically in PHP, and then switch over to Fusion just for the AFX rendering. We have a paradigm switch. That's basically the largest problem, I guess. So because before we at least tried to be as declarative as possible, now we are imperative or even functional, right? We have a more verbose code base, especially before PHP 8.1. It's still to be seen if in PHP 8.1 actually you have to write less PHP than you had to write Fusion before. That will be interesting. And back then, we compensated this by using a Kickstarter. Because the nice thing is, if you know a component's API, this is all the same all over the place, right? It's the same in PHP as in the Fusion renderer. So we just can say, okay, we kickstart a new card object, and it has a headline, which is another component we already kickstarted before. Then we say, okay, we want a Kaleidoscope image source, and perhaps a headline, and that's most probably a slot, right? So we wait a few seconds, and it generates all the required files for that. Yeah, we start with the Fusion file. There's it's basically a readily available Fusion prototype. Just throw a little Tailwind edit and you're done. At least that's what I think as a backend guy. It kickstarts our object and an empty factory because, well, integration is that what you still have to do yourself. Okay, further observations. At least I thought there were some. Yeah. So then it seems like I lost that slide. But so what can we still see? Yeah, I guess I have to skip that. So there's actually one thing that's still going on is that what about the integrational part? Can we somehow keep that for our integrators? And which is basically our synthesis. So we had the our thesis, which is well, there it is. Okay, try this again. Okay, so using this approach, okay, that's actually a very interesting thing I found out. At least I developed a much better understanding for what a component actually is, what it does, and what it does not. I mean, most of what we do here, like separating integration and presentation in such a rather strict way, you can do this in plain Fusion as well, but this architecture enforces that you do that. Naming things is more important than ever, right? You have this figure image thing, that's my favorite. So on the semantic part, it's an image, right? You can say in schema.org, this is an image. And it's nice if your presentation does not have the same name, so otherwise you just mix it up all the time. So we decided to go for image for the semantical part, and in the presentational part, it's just figure. The more complex these component structures get with all the child components and so on, the more we benefit from this approach, because this at apply cascade just doesn't happen anymore. It's really straightforward, right? You have one single entry point, and there you create all the objects, you give it to the renderer, and you're done. So there is no one interfering with that from the outside. And these components age very well. That's something I found out over the last 4 years that I use it now. Because, I mean, it was super easy to change components in the past, right? You just add another prop and you're done. But if you cannot do this easily, you also tend to think about what you're actually doing. Do we actually perhaps need a new component? Yeah, this actually goes very well then. So should you use it? So that's the typical answer. It depends, right? So I personally use it for all my presentation components. It might be, I mean, it's so for some components it's more usable than for others. For example, for complex components who do Elasticsearch queries that did the Elasticsearch queries before, these factories come in very handy because Elasticsearch in PHP works, in my opinion, far better than in Fusion. And but it's also non-invasive, so you can actually just install the package, and it won't break anything because it doesn't touch the props array. It can even be combined with props. So if you have something like that, you could just check it out. There's one thing where I would not recommend it. It's basically in the name. If you're still developing a prototype, so if you're just prototyping a customer object project, you don't yet know what components you need and so on, then perhaps plain Fusion and Monocle are your friend. So the synthesis, right? We had the thesis, which is plain Fusion. We had the antithesis, which is presentation objects. Where do we go from here? So I mean, all that's left is simple PHP code and AFX templates. So do we really need Fusion for that? Then can we somehow have the best of both worlds? I mean, if you have simple components like just mapping no-type properties to a component, that's really nice in Fusion. Can we perhaps keep that? Which comes to the point, who integrates the integrators, right? We still have to cope for their requirements because they're not only really enthusiastic PHP developers out there. There are also really enthusiastic Fusion developers out there. And if you recognize these two guys and know that they work at the same company, then you might imagine that there has been one or the other discussion going on this. So what can we do? Possible in the future. Currently, I mean, we still have Fusion at the base. AFX is rendered to Fusion. Presentation objects use Fusion to render themselves. Can we perhaps switch to something where you just write AFX or simple integration components? They are rendered, then transpiled to presentation objects and factories. And basically, perhaps the presentation components can even render themselves. That would be an idea. Let's see how we get there. And that's an interesting topic for the following year, I guess. So from me, that's it for today. There's this nice little package available. Currently at version 3 for PHP 7.4, including the Kickstarter. Version 4 for PHP 8.1 is in preparation. I basically I just wait for the for my next project that I can run under PHP 8.1, and then it will be done. And yeah, that's it from me today. Thanks for your attention, and let's see if there are any questions, and if we have still time for them.
Much, Bernhard. Thanks very much. Awesome talk. So you also get your present right now. Oh, we forgot it again.
Every time.
But we hope you like gin.
Yeah, I think I can make use of that. Yes.
Okay, cool. Yeah, thanks again for to Tech Division for sponsoring this.
Thanks a lot.
And yeah, thanks again, Bernhard, for your great talk.
Yeah, great.
Yeah, so I guess the schedule is really tight. So the next thing is on the center stage, and I guess it happens very soon.
Yep. So thanks for joining us here for the last talk on the studio stage, and yeah, let's all come together for the great finale of this conference.
Yeah, thanks.